All right, we can commence the meeting.
Okay, great. Welcome everyone to the August 24th Electric Utility Advisory Board meeting. Can we go ahead with roll call, please?
Yes, Matthew Portilla.
I'm here.
Ramsey Stevens is not here for the roll call. Brian O'Blander.
Here.
Eric Jeffers.
I'm here.
And David Sims.
Here.
All right, we're all here.
Okay, great. David, do you mind leading us off with a Pledge of Allegiance tonight?
Okay. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
For all. All right, thank you very much. Are there any additions, deletions, reorderings tonight on the agenda?
No.
All right, and there's no further presentations. Are there any public comments?
I did not receive any.
Okay, and there's no minutes to approve tonight, correct?
That is correct.
Okay.
Now, Ramsey did send in those emailed questions. I'm just letting you know. I mean, how you handle it is your decision.
Well, I guess we can read them into the record discussion.
Okay.
All right, so we're just going to move right into the unfinished business, the discussion of the Horizons Energy Integrated Resource Plan. All right, so we're just going to go ahead and kick it off with board member comments, or do we have any comments from our liaison?
This is at Liberty. My video is not working for some reason. I don't think it was enabled, Suhey. But I am here, and we do have our friends from Horizons Energy, and I believe they're going to walk us through an update on the work they've done for us. And I know that I went through some items with them a few days ago, and was pleased to see how well along they've come with the work, and hopefully have some new and useful information. Also remind the advisory board that we were looking for feedback from you all on what I would call the glide path, if you will, on CO2 reductions and the path that you would like to see us on. Right now we're currently operating on a draft which I threw out there as a starting point, but we'll be looking for more feedback from the community as to what glide path you'd like to see. So I'm sure we'll get to that as we go through the discussions, and obviously tonight is not the last night to comment on that matter. So,
okay, so should we start with their update then?
Sure, great.
Okay, good evening, everyone. Thank you, Director Liberty. This is Greg Turk from Horizons Energy. So we met with the electric utility staff yesterday and talked through some of our updates that we've achieved in the last few weeks since we last met. I got an echo on my.
Yeah, hold on a second. I'm not sure who's speaking, but if everybody could go on mute, that would be helpful. If you're not currently speaking.
I think that might be Suhey's feedback.
Okay.
I try now.
Testing.
Right.
Okay, so we're working with the city. One of the things that we're doing is we've data requested a variety of historical information regarding the utilization of the plants, the costs of resources, the ability to get power in and out of the city. And so we, I believe, have finished up, unless there's except for just a couple of things, the underlying data required in order to do our base case for the integrated resource plan. We provided and discussed the table of contents for the IRP report. We described I think probably some slides that we'll show in a bit regarding the emissions levels within the city versus the surrounding area, both Florida Power and Light, as well as the general Florida community, which is called the FRCC. We stepped through the resource expansion options to date. And our next deliverable is to provide preliminary cases for review to the electric utility. We're looking to do that in a couple of weeks. And so that takes the form of showing the level of demand, both energy and capacity required over the forecast horizon, which we right now are saying is 2023 through 2042. And so it's the level of demand, and then under base case conditions, which resources would natively supply that demand, given that we use this model that allows us to identify type and timing of new resource additions while considering a variety of other things, including the cost of achieving carbon compliance.
And Greg, this is Ed. So for the benefit of the members of the advisory board and the community that may be listening, we provided you with some rather important data inputs in terms of unit retirements, in terms of things that we have in our portfolio, what we anticipate for planning purposes, not yet final, but planning purposes, what those unit retirements would be. So I think as we go through this, it would be helpful for them to see the input that we gave you that is really underpinning the model to some extent, right? Because I think that's
okay. Is that something you want to share tonight, Ed, or?
I think so. We should get it out there for discussions, because it does drive some of the conclusions that the model points to, right?
Okay, then let me.
So it's worth.
Ed, I have a quick question.
Yes.
How linked is the Florida Municipal Power Pool to our current assets? I mean, the asset retirements, I'm assuming, are under the umbrella of the Florida Municipal Power Pool. Is that correct?
They are. Some of them are our own assets. So let's talk about them. So let's talk about the power pool first. The Florida Municipal Power Pool is a pool of municipals who all have their generation assets in a common pool. That pool is roughly 1,300 to 1,400 megawatts of capacity, if I remember correctly. Is that correct, Brian King? You know, Brian's our assistant director for Power Gen.
Yeah, that's pretty good.
Okay. So our assets, our power plants, for example, our individual generating units at our plant are available to the power pool, the Florida Municipal Power Pool, for dispatch. They are available on what's referred to as an economic dispatch, or possibly if there's an emergency, they might dispatch them as well, but typically they're available for economic dispatch. So we provide the power pool with very detailed startup costs, startup times, heat rates, if you will, how many BTUs it requires to produce a kilowatt an hour, variable O&M, fixed O&M, minimum run times if we have them, staffing costs, things like that to operate the plant. They have that same information for every unit in the power pool, and then they will dispatch units in the power pool to meet the load of the pool, to meet the requirements of the pool on the most economic basis. So the most economic unit dispatches first, the least economic unit dispatches last. So our units do contribute to the pool. They are rarely used by the pool, but I should say they're seldom used by the pool, but it's not rare for them to be used. We get called probably, I'm going to say 6 to 12 times per year, roughly, would be my rough estimate. Brian would have more specific numbers. And we might run for the pool anywhere between, let's say, 2 hours to maybe 10 hours or 12 hours at the most. And that might be a single day in a week. There could be weeks when it goes on, for 3, 4, or 5 days, where they start the unit up and shut it down. So our unit retirements would, of course, show up in the pool. Our units are also dispatched for our own needs under our existing contract with OUC. There may be times when the most economic solution is for us to dispatch our own plant, and that's happened as well. So that does happen on occasion. I'm not sure if I answered your question.
Okay, so no, that does answer partially. And this is a question I'm just going to throw out there because it sounds like we are integrally linked to the Florida Municipal Power Pool, and our changes are not necessarily the changes that we have in the assets, and our goals with carbon emissions is integrally linked with what the FMPP does, right? Florida Municipal Power Pool.
That's correct. However, the decisions on whether to retire a unit or not retire a unit are ours. The pool does not make those decisions. We make the decision on what we want to do with our asset, and then the pool either has it or doesn't have it.
Got it. Okay. That answers my question.
Okay. Thank you. I think that I appreciate the questions. I think it helps educate everybody on how things actually work. So those are good questions. All right. Let's see what Greg's got for us.
So can you see my screen?
Yes.
Can you? Okay. So you're actually, the one place that we have the latest updates is actually within the model. So the model that you're seeing here is called Encompass. It's a utility power planning model provided by Anchor Power Solutions. And so this has the latest summary of the, should be, or extremely close to the latest summary of the unit, both commission dates, that's the dates that units come online, as well as retirement dates. So a lot of the purpose of this plan is to determine type and timing of new resources. But when you see a commission date down here, it's going to correspond to something that already exists, and then its corresponding retirement date. So I believe that the things that Ed wants me to look to point out here are, let's start with some of the existing assets like GT1, started up in 76. And right now we have a placeholder of mid 2027 as a retirement date. We have there's a resource called Lake Worth CC, which is a combination of both a combustion turbine and a steam gas resource. Also, it was commissioned in 78, and the steam portion that's looking to be retired in 23. However, there's the GT portion will carry on, and so that's also anticipated to carry on until 27. Here's the steam piece. One of the steam pieces retiring. Some of the other assets key in the system are ownership shares of the Stanton 1 coal resource, and that's they're looking to either retire or back out of the ownership share of that resource. I believe the controlling owner is saying retirement by end of 2025. There are little units that are used for emergency purposes. They're internal combustion engines. There are 5 of them, and they're used only for black start or emergency situations. St. Lucie is the nuclear ownership share, and it goes out through 2043. So all of these resources are acting as an important basis from which we begin to investigate the need for additional resources. Key resources, and I'm sure you want to say a few things. The other things I'll just point out here are the FMPA projects, which perhaps Ed would want to provide more color around.
Yep. So let's step through the individual ones. I'll start at the bottom and work my way up in terms of our assets. So let's talk about Stanton 1. So Stanton 1, we've been in that project. That's an FMPA project. Stanton 1 is a coal-fired plant. It's owned by Orlando Utilities Commission, and a portion of that plant is owned by FMPA. So FMPA owns a portion, and we have a portion of FMPA's portion. That translates to 11.1 megawatts of capacity for us. So OUC is the controlling owner. They alone make the decisions on what to do with that plant. Obviously, we have some input, but they are by far the majority owner, way beyond what we or FMPA own. So they make the decisions. They've decided that they will retire that unit by the end of 2025. a decision that we actively lobbied for and very much support. That unit burns primarily coal, but it does burn a significant amount of natural gas as well. The next unit up is the St. Lucie. We're in that project through FMPA. That is the FPL-owned St. Lucie nuclear plant. FMPA has roughly a 100 megawatt slice of the plant. That's St. Lucie 2, I believe. And our share of that is 22.2. We are the largest holder of ownership interest and capacity in that unit within the FMPA group. So we're roughly 24 to 25% of FMPA's interest in that unit is assigned to Lake Worth Beach. Next unit up in terms of things that we own, the S3 steam unit. That is a 25.6 megawatt steam unit commissioned in 1967. It does still run when needed. Brian's staff does an amazing job of keeping that unit available. It is obviously quite old. The steam turbine and the generator are in unknown condition, meaning that they haven't been opened up for inspection in many, many, many years. Our plan is to retire our steam assets when the second tie line to FPL becomes available. So that's currently planned for December of 2023. And our plan is when that tie line becomes available to retire the steam assets. Why are we going to retire the steam assets? Well, they're costing us upwards of $2.5 million a year to operate and maintain, just to keep them in a state of readiness for the occasional run. Our entire power plant at the city is intended and really has served as a backup to the single tie line. So if the single tie line were to fail, the thinking is that the power plant would carry the city. Well, that's good news and bad news. The good news is that's what it's intended to do. The bad news is you can't do that because the city's loads during the greater part of the year are greatly in excess of the power plant's capacity. And the power plant is quite outdated and in quite poor condition to be able to be relied on to do that. So we try not to use it, but if we have to, we do. We're concerned there that obviously it's a very high cost, and the cost to repair any component would be so high as to be the end of the life of the unit. So the plan is to retire that unit. Again, that's 1967 vintage. We hope it lasts till the end of 23. And it does run occasionally. We do test starts on it to keep the station personnel proficient in the operation, the ability to start it up and operate it. And then we shut it down. And of course, it is available to the pool if they need it, and available to us if we have a contingency where we needed it. The next unit up in that stack are the M units, M1 through M5. Those carry 2 megawatts each for a total of 10 megawatts of generation capacity. However, we do not use them as capacity for capacity planning. They are effectively black start units. They were previously, I believe, locomotive engines. 1965 vintage, they're lined up. Brian again keeps those with his staff in outstanding condition relative to their age. They do start them, bring them up to speed, make sure everything works, and then shut them back down. In the event of a black start, meaning that we lose the tie line or FPL loses the transmission system, we could start those up, and we have had to do that. We use them to carry the load in our switch yard, get the transformers energized, begin to restore operation for the city in an island mode. Lake Worth Solar 1, we've talked about that a lot. It's the city's own solar plant on top of the landfill, 1.7 megawatt unit. Then we have the combined cycle. The combined cycle is a combination of GT2 and S5. They work in combination with each other. So they were commissioned in 1978. We refer to that as a combined cycle unit. The gas turbine produces power. The waste heat from the gas turbine produces steam, which in turn spins a steam turbine. The steam turbine is roughly 10 megawatts. The gas turbine is roughly 20 megawatts. So together they're 29.2. Again, the steam side, just like S3 on steam, very expensive to maintain. The boiler is in very difficult condition. I'll point out that S3 and S5 both rely on cooling towers that are significantly deteriorated and would need to be replaced. The subterranean piping back and forth between the plant and the cooling tower has collapsed catastrophically at least once. And that turbine and generator are also in unknown condition. So one question might be, if they're unknown condition, why don't we open them up and see what kind of condition they're in? The problem with that is, in order to do that, we need to take an extended outage, meaning they would be unavailable for weeks once we open them up. So if we had a contingency situation, we wouldn't have them at all. And the reality is, if we find anything significant going wrong with them, we can't afford to spend the money to fix it. So the decision was made a number of years ago to basically just shepherd those through to the end of their life, hope that they make it through to the point when we have the second tie line, and then retire them and absorb the benefit of no longer having to keep those alive in the budget. They are not always used for capacity in our nomination. S3, for example, is rarely ever used for capacity nomination. So we've assumed that it doesn't exist other than as an emergency device. And the combined cycle is used pretty much monthly in our capacity nomination. If we step up to GT2, so GT2 is the gas turbine side of the combined cycle. That's a 1978 commissioning date. It's actually a 1975 vintage turbine design. And the procurement, it went live in 78, from we can tell in the records. We would propose to keep that unit, although you'll notice that we put a 2027 retirement date on GT2. And we've also done that for GT1. It would be presumptuous to assume, when doing a long-range capacity plan, that these units would be available indefinitely. So what we've said is we're going to use sort of a rolling five-year understanding of their ability to continue to operate. Once we do get the second tie line in service, we would then be able to take these units out of service and open them up and see what the condition is. On GT2, we did an overhaul of the turbine and compressor section in 2017 into early 2018. So the turbine and compressor section are in pretty good shape. We spent $1.2 million on the turbine and compressor. The condition of the speed reducer or speed increaser and the condition of the generator are unknown, but we would want to take a look at that probably sometime in 2024 and try to get a better assessment on the condition of that as to whether the retirement date is reasonable. GT1, 1976 vintage. Again, we've put an assumption in there of end of life of 2027. Similar to GT2, sometime in 2024, we might seek to open it up and see what we have. If the units can be overhauled and repaired to extend their life at a reasonable cost, that's something that we would do. We'll take a look at what capacity sells for in the marketplace and determine whether it's worth investing in repairs or overhauls. If it's not, then we would probably either retire the unit at that point. I hate the thought of just running something to destruction, but that's likely what could happen. They're in unknown condition. And as I said, right now with a single tie line, I can't afford to open them up just to take a look and see what might be wrong with them, because the exposure during the outage is too high. And the question would be, well, now that we know that the thing is ill, what do we do with it? And are we going to pour a lot of money into something that we only need for another year and a half at this point?
And just real quick, I see we're going through this list. I just want to point out that GT1 is a oil only fired machine. The M units are oil only fired machines. I see that it's got gas and oil, and S3 is a gas only machine. It was bunker oil at one point, was converted to natural gas. So there is no oil available on S3. There is no gas available on the M units, and no gas available on GT1.
Very good point. Thank you. So those units were not, let's say, GT1 and S3 or the oil-fired GDM units, rather, were not sold as gas-fired units. GT1, in theory, could be converted although at this stage of its life, I'm not sure what the value of the economics would be for that to convert a unit to gas that's really going to run. We do have some maintenance, some costs that we're going to have to, spend dollars. We have to spend. GT2, I believe, may need a stack for simple cycle operation, or I think those were not much more really than silencers when they were first sold. So it might need a stack replacement. And M1 through 5, remarkably, those are reciprocating engines, large diesels, and they could continue to run. I watch these antique car shows; they keep those old engines running forever, right? So I don't know how much longer you can keep it going, but I suspect for a while yet. So that's a rundown on the portfolio in our own plants. Of course, the solar stuff is relatively new. They come with 20-year power purchase agreements. So was that helpful for the group? And are there any questions?
I just want to say, no, I truly appreciate that breakdown. Thank you.
You're welcome.
Yeah, I know you mentioned, you said it, but I just want to clarify. When you inspect it, you said, you can't inspect it because you got to take it offline and we only have got one tie line. You have to have a few weeks to open it up and inspect it. There's no quick thing, right? There's no way you could do it just in a few days.
Yeah, that's a very good question. There are some limited inspections that can be done with the use of a borescope, by opening up a port on the engine and sticking the borescope in and taking a look around. But that's going to give you a very limited amount of information. You can get into the inlet plenum and maybe check out the first stationary, maybe the first rotating, maybe second stationary set of blades if you're lucky, to look for blade cracking or boot cracking or any other foreign object damage or shedding of metal. But absent really tearing it apart, you can't tell an awful lot on a turbine itself. The process requires removing the upper half shells. You remove all of the insulation. It's a horizontal joint machine with very, very, very large bolts. We don't have the staff to open these things up, let alone the equipment to do it, and then physically open it up and do an inspection. In some cases, the rotor has to come out so you can do an inspection in the lower half, and you've got bearing issues, and you've got the gearbox. So typically, I would expect it to be every bit of a week, a solid week with millwrights or machinists tearing the unit apart and inspecting it. Some of the parts would have to go out for further inspection at a service shop. Then you've got the time to repair the elements that stay on site that you can't remove, and then to reassemble everything. So I would say even a relatively simple outage, once the rotor comes out, you're looking at a minimum of a month, probably more.
Okay, yeah, that makes sense. To do it right, to really do it thoroughly, I mean, it's just unavoidable to take some time to tear all that down.
Right. So the turbine is, for those of you that haven't seen them, it's much like a jet engine, except it was never intended to be on a plane. They're obviously much heavier. So if you have any kind of foreign object damage, something that goes through the first stage, it has no choice but to come out the last stage. So this, these whirling blades, if you will, it's like a big Cuisinart of tightly spaced things that are operating within a few thousandths of an inch of each other. As something goes through it, literally, destroys the machine. So we may have that type of damage on the generator, whether it's a steam turbine generator or the gas turbine generator. The ability to do inspections is very, very limited. There may be some ports that you can open up on the end. At least one of these generators is in a hydrogen environment, so the hydrogen has to be vented. Obviously, we all know that hydrogen is a highly flammable gas. You vent the hydrogen, you purge and make it safe, and then you can open up some ports and do some inspections. But typically speaking, that's not going to allow you the ability to really inspect what are called the windings, particularly the ends of the windings of the generator, where all the twists and turns are, which are insulated and dipped in what I would call like a Gliptol red material. And over time, you get breakdown of that insulation. There are also, the right way to do it is you remove the end bells. The generator is a long cylindrical thing. You remove the end bells, which have to be rigged off with a crane. You can then remove the lower bearings on the one end and basically slide the whole rotor out of the generator. And then you inspect the rotor windings themselves, other than just the end windings. the interns. If that has to be rebuilt, you're looking at probably $500,000 to $1 million minimum to rewind a rotor, and then you have the stationary windings, which can only be inspected once the rotor is out. So once you make a commitment to open up a generator, I'd say that you're looking at a minimum of a month, and that's if only minor things have to be done. Recognizing that the windings, the shims, the insulating, the Mylar packs, all of that stuff that's inside that are not shelf items. They might be custom fabrications. So you could be looking at, it wouldn't surprise me if we did an outage like that, or Brian came back and said it's going to be, 6 months to a year before we get our generator rewound and get it back. Brian, correct me if you think I'm wrong on that estimate.
No, I think you're right on, and especially with the age of these units, there's not going to be a shelf item from a generator from 67 or 78 or 65. I mean, those things just aren't kept. The technology's probably turned over 10 times since then. So it's more than likely any parts you need or pieces you need are going to have to be custom fabricated.
Now there are the equivalent of the junk drawer. We all have a junk drawer in our kitchen, right, with a full of odds and ends parts, or it's in the garage, right? There are people in the business of buying up old equipment like ours and scavenging it for parts. So it's possible that there could be a generator or a generator rotor someplace in the country that would be available on short notice that may have already been rewound, but that's going to come at a pretty steep price, and we have to trade our existing rotor for theirs. And of course, bring it back, align everything, assemble it, and put everything back together. So it's a rather substantial investment. So I think it really at this point, I mean, I've done many generator outages in my life, everything from motors that are 2 megawatts all the way up to 680 megawatt turbines with rotors that weigh 70 tons. I've done a bunch of these. So my concern is that there's no way we're going to open these up and say, oh, they're all good, just close it back up. We're going to find something that's going to require some significant investment, and that investment isn't going to make sense. That's my concern. So at this point, we're just happy to get to the end of life, or have the end of life be sometime after the second tie line gets built. And that you kind of develop personal attachments or emotional attachments to equipment. This equipment has served the city so well since the 1960s and 1970s that it's amazing that it's still running today, and that Brian has worked with staff at that plant to keep the operating proficiency where it is, to get it to run every time we need it. He's just done an outstanding job with the team in achieving that. Okay.
Okay. Ed, did we want to step through the environmental slides?
Yes, we should.
So Kathy Jones, who's on the call, actually did a level of research in investigating the some of the goals and also some results from our spring 2022 Horizons advisory for the state of Florida. Kathy, would you mind jumping in and stepping through the 2 slides?
Oh, sure, no problem. So what we're looking at here is the orange line is, well, these are carbon emissions, and it's not in tons, it's in pounds per megawatt hour. So this gives you a flavor for the carbon intensity of the energy that's generated on the system. So what you're seeing on the orange line is from our spring 2022 Horizons Advisory Service for our quote business as usual. It doesn't reflect the specific targets of the individual utilities because we're looking at this from a national perspective. So from a national perspective, we were targeting a reduction of 35% from carbon emissions off the 2020, or no, I'm sorry, not 20, but off the 2019 level of emissions, and then going down to, I think it's like a 65% reduction And that was just to reflect the fact that a lot of the utilities and some of the states within the lower 48 have enacted their own quote net zero type of carbon emission targets. So then Florida
So-
Power
so-
and Light.
So Kathy, let me put this in perspective for everybody. So that orange line then is your assessment of the Florida market based on publicly available information. So the FRCC is the Florida Reliability Coordinating Council. That's basically a transmission looking organization, but it really encompasses all of peninsular Florida. So, right, so this is publicly available information on where you believe the pounds per megawatt hour for the system will be, for that FRCC system will be as you go out to 2050, correct?
Well, actually, no. So
Okay. All right.
it is reflected, as you said, that part is correct, that it's reflective of the full peninsula and of Florida and the FRCC transmission region. But what you're seeing is the trajectory that we assumed in our advisory service for the business as usual that reflected the target reductions of the 35% by 2030 and 65% by 2050. Some of the utilities within the peninsula have more aggressive targets than what we assumed from a national perspective, because we were solving for a national carbon target, not a peninsula target. And so
Okay.
this is just the end result of what that national target did to the peninsula's emissions.
Okay. Thank
So then I went back and looked at Florida Power and Light specifically and looked at their specific targets and what the pounds per megawatt hour would be. Because they're targeting off of a 2005 base year versus we were targeting off of a 2019. So they're looking at a trajectory off of 2005 and going to net zero by 2050. The next slide actually shows you what that trajectory looks like for Florida Power and Light. So the orange line again is Florida Power and Light, and their axis is on the right-hand side, and the Lake Worth target is on the left-hand side. So you can see, you're looking at 50 million tons versus 300,000 tons from just Florida Power and Light versus Lake Worth Beach utilities. But the key thing that you can draw from this particular graphic is the trajectory. So by the 2005 timeframe, yes, FPL is lower because they're targeting like 75% reduction, whereas you were targeting 50% reduction. But you can see that the shape of the lines are the same, with FPL getting a little bit more aggressive post 2025 than the assumptions that you provided us with, Ed. So
Right.
that's the key takeaway there. But it was like, okay, you're both kind of targeting the same years where you're going to take that next step.
So
of
this
getting to the net zero.
This is an important slide for us to all absorb, because the blue line is the line that I said, as a starting point, let's start here, right? What we'll be looking for from the advisory board and ultimately from the commission, based on feedback from multiple iterations of modeling, what is the trajectory that you would like to be on? Because the trajectory that you want for CO2 reductions is going to drive the resource decisions that you make, and that staff then executes. So that's important. And you'll see that even though I thought I threw out something aggressive, the FPL target is even a little bit lower. So there's good news in that, because realistically speaking, there are three primary suppliers for us in the wholesale business in terms of us getting our wholesale power, which is greater than 98% of what we need. FPL is certainly one, Florida Municipal Power Agency, and OUC. They're the three big players. Right after that, it's probably Duke, but it's a little bit more difficult for Duke to wheel power to us, but they certainly could be a player in the future. But we can see here that the dominant player, certainly in the southern half of the peninsula, is FPL. So we believe that our emissions, for example, in their supplemental power contracts, if FPL were the winner down the road, that might be what we would see. FMPA is probably going to have a very similar curve. Theirs hasn't been announced yet, and OUC is probably as aggressive as FPL. So the good news is that if we look at our supplemental requirements, which we anticipate we're always going to have a supplemental requirement, that orange line is indicative of what the market is going to allow us, or what the market will be able to bring us.
And that would be, I know that Florida Power and Light has committed to this net zero by 2050, but they still don't have a really good long-term strategic plan of how to achieve that. That's why we haven't really reflected that in our forecast, because a lot of these utilities across the US are committing to net zero without a specific strategy of how they would attain it. Now, we've seen Florida Power and Light saying, okay, we're going to build solar, we're going to build batteries. They're retiring the coal. There's going to be no coal in Florida. So, and they're limiting their gas expansion as well. And I just saw this week that they have signed on to possibly do a small modular reactor in Florida to help them attain this zero emissions target.
So I can speak a little bit based on what I've read and talk in the industry about what FPL is going to do and what they've actually published. So obviously FPL, being a part of NextEra, they're making a massive move towards solar. Well, of course, they have a huge customer base, so having solar be material, means an awful lot of solar. But having said that, they're going into solar in a very, very big way. I do expect that they will do a small modular reactor as you get out in time. And I don't think that's more than probably 10 to 15 years out before we'll see something like that happen. That's my opinion. I haven't seen that anywhere, but I think that's coming pretty quickly.
Oh yeah, no, that's going to be in the late 40s, if ever.
They've also indicated that they've been approved by the commission in Florida to go ahead with some trials. They're going to begin blending hydrogen into the fuel source with their gas turbines. So gas turbines that they have today are going to begin to be fed hydrogen together with natural gas. So they are going to be using technology to separate out hydrogen molecule from water, I believe. So I believe what they're going to do is they're going to grossly overbuild solar. They're going to use solar to produce hydrogen, and they're going to blend hydrogen into their turbine, into their gas turbine fuel, which will then decrease the amount of natural gas that they burn. Whether you'll see these very, very large turbines, tens of thousands of megawatts combined of turbines, they probably have 20,000, 30,000 megawatts of gas turbines. Whether you'll see them on 100% hydrogen by 2050, I don't know, but they're certainly starting on that now, and they're going to start blending hydrogen in. So I think there's some key differences here when we talk about zero and when we talk about net zero. So when you talk about net zero, it allows you to bring in other things that you've done that reduce carbon and apply those to things that you've done that didn't eliminate carbon. So you net to zero through algebra. I suspect that they're going to be doing that as well. And I'm not saying that that's not a valid strategy, but I suspect that they're going to be doing that as well, taking credit for carbon emissions for other things they've done, and then using that to net to zero or net lower on their own emissions. And I think many utilities will be doing that, and corporations.
Well, that actually dovetails on a good point, which is as you move down these carbon reduction trajectories, the cost of compliance increases at an increasing rate. It's not shown on this graph, but to achieve a 60%, let's say, reduction is somewhat easy through redispatch and through relatively inexpensive technology switching. But once you get beyond 60 to 80, it's kind of moderate. And getting from 80%, let's say, to 100% is extremely expensive. And one of the things one of the main reasons for that is, at least with today's current technology mix, is the lack of economic firm capacity. So in order to get to that, we need a longer term battery than a 4-hour or 6-hour battery, which is kind of state of the art now, or we need technological breakthroughs in some other area, like the cost of hydrogen or the cost to produce nuclear or something else.
So let's do a little exercise to run test these concepts with folks to understand how this begins to work and where these diminishing returns or greatly expensive changes happen. So we continue to get 22 megawatts of nuclear. Coal is retired. Let's take an average day for the year for us, which is, let's say, 55 megawatts, but for the sake of this exercise, let's call it 60 megawatts for simplicity. We have 22 megawatts of nuclear coming at us every day. So we've got to get from 22 to 60, right? So we need another 38. Well, we've got another 38 megawatts of solar coming at us. But that solar is only going to come at us during the day. It only makes solar when the sun shines at the moment. How do we make power once the sun goes down? Now I need some form of either storage or fossil fuel to get through the night to then get back to the sunshine the next morning. So in order to now get my CO2 reductions in the overnight hours, I have to have had a lot more than 38 megawatts of solar, maybe another 38 megawatts of solar. I have to have put it into storage that will then draw down over what could be a 12-hour period before solar starts producing again. Right now, the batteries are typically 2, 4, 6-hour drawdowns. They haven't, if you want to draw down over 12 hours, you have to have a much different type of battery because you're going to have to recharge it as well. So batteries, for example, if you get a 100 megawatt hour battery, that 100 megawatt hour will give you, well, let's use a simpler number, 80 megawatt hour battery. Well, 100 is fine. Let's use 100. So if you have a 100 megawatt hour battery, it's going to give you 25 megawatts per hour over 4 hours. So we might need 100 to 150, maybe even a 200 megawatt hour battery that we can then pull 25 to 50 megawatts out slowly overnight to get through the night. So when the sun comes back up the next day, so we could, right? So we build a whole bunch of extra solar, store that energy during the day, then take it out of the battery overnight. So that battery then becomes very, very expensive. So as you get further and further out, you realize that it gets more and more expensive to get that last little bit of carbon. That's the bad news. The good news is that just as in every other technological development in the history of mankind, things that appear to be very, very expensive today are really a technology challenge that gets solved by investment and invention as you go forward, right? So there may be something that comes in the market 5, 10, or 15 years from now that greatly revolutionizes the ability to reduce carbon. Maybe carbon capture really takes off, and carbon storage, things like that. So it's not all doomsday here. I think we have a path forward, but what we're doing today is an important part of that. But it gets you to start thinking, I can't just solve this all with solar. I get to the point where I now have to put solar into storage so I can begin to offset the carbon fuel that I have to use to get me through the night or through the peak periods. The other anomaly, the reality of solar is it's not a spinning resource. It has no momentum to it. I'm a mechanical engineer, but you need momentum in your electric system to carry through the sags and the swells. Well, solar doesn't do that for you. It's either on or it's off. It doesn't have the ride through capability. So you're always going to have something with some mass to it, or a rapid response battery that's following load and smoothing the curve for voltage control, voltage regulation, things like that. Okay.
I see that Ryan has his hand up.
Yeah, I had a question. The documents I saw in the last meeting provided that FPL's target date was 2045 in those documents, not 2050. Is that still accurate, or did they change it to 2050 recently?
They changed it in June. And so this reflects their latest targets from June.
Okay, so it's now 2050.
Yeah.
Okay. Yeah, that-
I have a quick question. Just this is mostly for Ed. So I guess FPL's thesis is that at a certain point, storing energy as hydrogen with leftover, like, generation during the day becomes cheaper than storing it as batteries, given the current economics and maybe even future economics. Is that correct?
I companies like FPL, which do a very good job of this, are probably not going to bet on this one technology at this point. So they're going to have a lot of different options to get there. So certainly battery technology is something they're going to continue to pursue, and I think pursue it heavily. But they're also going to go after hydrogen.
Okay. And just like they're retrofitting a turbine or something to hydrogen is something that they're willing to take on, I guess.
Yeah, they are, and that comes with risks too, because those turbines were not designed to burn hydrogen, and the manufacturers that sold them their warranties and their service contracts all presumed natural gas fuel at 1,020 to 1,040 BTU per cubic foot, specific gravity, a Wolbe index, all that kind of stuff. So now you're introducing a fuel into the turbine that it was not designed to operate at. Now those turbines are operating at extremely high temperatures with highly advanced metallurgy, single crystal structures in their turbine blades, internally cooled, very, very complex pieces of equipment. So they're taking some risk and betting that they can begin to blend hydrogen into these machines without damaging them. And there's also, of course, the realities of handling hydrogen. Not that handling natural gas is 100%, right? You've come from the business, but you can imagine what it is when you have hydrogen. I've worked in hydrogen plants that didn't burn hydrogen, at least not by design, but we had a lot of hydrogen in the plant, and that gets your attention in a hurry. And
yeah, it's dangerous stuff, but it is dense in terms of energy storage.
Absolutely. And the personnel safety factors are intensive. You can imagine, a hydrogen leak in a plant. You can't see it. It's odorless. You don't know it until somebody falls over, and you get to them and you fall over too, right? So it's very, very dangerous.
Okay. Yeah. Thank you. I just wanted to hear a little bit more about that.
And I was going to ask a question too about our targets. Do we have to be committed to the 2050 target as a net zero, or is this just a guideline? Because from what I'm hearing is that the closer we get to net zero, the more expensive it becomes. Is there like a happy medium, like a net 20%, or net, like net 30, net 40? Like, is there some kind of range where the cost becomes too prohibitive to go further?
We believe that there is, but now I'll take off my engineer hat and put on my public servant hat and say, who's the public servant who's going to step out and say we don't have a plan to get to net zero?
There's a cost with not doing it as well.
Correct.
I mean, you can't ignore that and by 2050, people are shocked when they hear this, but the sea levels expect to be 12 inches higher than it is, 10 to 12 inches higher than it is currently. So it's not a long time horizon with already a lot of built-in factors that are going to change the world and the way we operate. So
I agree with the sea level part, but the question is, where is this natural gas going to go? And if everyone is making their targets to be zero by 2050, wouldn't the supply and demand curves show that the price of natural gas will actually become cheaper as everyone approaches zero?
It'll be cheaper, but if they price the damage of CO2 into the natural gas, then they can make it more expensive. But that's a policy decision. That's not ours.
Well, but you're also thinking that infrastructure is only available to use for natural gas. There's nothing that says you can't do some upfitting and run hydrogen through the natural gas transmission pipelines that we have currently. And if there's a cheap effective way to create it, then, you know, the FGT pipeline that comes down here one day might go, okay, today we're switching off natural gas and we're switching on to hydrogen, and we're purging the lines, and you got to jump on. So I you know, there, just because there is a possibility of that doesn't mean that that's the actual way we're going to go. So I mean, all of those are much deeper, bigger questions than how are we going to hit our targets as a community in the next, you know, 15 years. And I believe what was our time horizon for the actual plan that we're with the genesis of this? Ed,
2050.
what was that 20? It was 2050 time horizon.
Well, the resource planning is really focused around roughly a 20-year plan, but the long range is 2050. I think, you know, on the pipeline side, and I did spend a fair amount of time in my career trying to get this done. I was unsuccessful, but you're 100% correct. I don't think the pipelines are going to go to, let's say, 100% hydrogen. I think what you will see, as a matter of fact, I know what you will see is blending. The thing that they're starting to blend now, which I tried unsuccessfully to do close to 20 years ago, 15 years ago, was actually it was closer to 20 years ago almost now, was to blend landfill gas, a low BTU gas, medium BTU gas into the pipeline, begin to blend it in as a renewable resource. I got little or no traction 15 plus years ago. It was actually rejected by FGT on that concept from the Brevard landfill, starting with about 2,000 decatherms a day of medium BTU gas. But you're going to see that. I think you'll see hydrogen blended in. The real challenge on the natural gas side, and I know Matt's very familiar with this, is to make sure that the pilot lights don't go out in businesses. So if you're using a compressor, that's a different story. But if you have an atmospheric burner, otherwise known as a stovetop or a hot water heater pilot light or burner, atmosphere grill, a pool heater, a gas light in your lawn, those types of things. If you change the fuel mix substantially, you could run into problems. But I think that over time, just as those same devices can burn propane or butane or natural gas just by changing certain components, I think that's going to happen. I don't think you're going to see pipelines, certainly in the lifetime of anybody here on this phone call, I don't think, unless there's somebody who's a 2-year-old, I don't think you're going to see pipelines go to zero natural gas. I think natural gas will continue to be in the pipelines. And don't forget liquefaction. You know, that gas is going to turn into a liquid, and it's going to be shipped to other parts of the world that aren't buying into the orange line or the blue line.
All right, that's where I was getting at with that, because natural gas isn't just going to disappear entirely. So if I don't know, I can't predict 30 years into the future if it's going to become cheaper or more expensive based on our discussions here. But if there was a way that we could model that, where we can see how the other players are doing it by their 2050 models, and we have like an extended timeline of say 2055 or 2060, you know, then we can determine, you know what to do based on that trajectory.
I don't think it's going to change very much what we model. We're making resource decisions within the next 20 years, really, in this model. So we can certainly look at that, but I don't think we're going to spend too much time speculating what we're going to do 22 years from now, because that's going to change dramatically well before that. So these resource plans or integrated resource plans really should be done every few years. We are actually, by the way, in the minority, I believe, in terms of small municipals that are actually studying this in this level of detail. That's, I believe, unusual for a municipal of our size to be going through this level of detail and study. That doesn't mean we shouldn't do it, but we're already thinking much further ahead than any other small municipal in the state of Florida that I'm aware of. Frank may have some input on that.
I'm a big fan of this level of detail, and just kind of from hearing all of this, it seems like the powers that be, if you will, the FPLs, the FMPA, they have more aggressive targets than we do, and we're buying our power from them with contracts. I see no reason to more aggressively adjust our target from what it is, leave our options open. that gives the most flexibility in the future of our sources of power are doing the thing. We can be more aggressive about that, but it seems quite reasonable to me. And by having something less aggressive, we can have further options to ensure that our small community, has affordable power like that. Yeah, I don't know. I like the way that graph looks.
I think things that are readily within our control, when we look at it, really in the next, I would say, less than 6 months, we'll be making, or should be making a decision whether we're going to buy even more solar beyond what we've already bought. And those would be, for example, 20-year power purchase agreements. So that's going to make a big dent in what we do over the next 20 years. So I think we need to focus more on what we're going to do over the next 20 years. I think we need to be mindful of having a long-term strategy to get to net zero by 2050. But we can't make decisions today about what we're going to do in 2044. I think we want to make sure that we make good decisions about what we're going to do in the next 6 months. That's going to put in place 20-year contracts for significant amounts of solar. And I'm personally advocating that we make a very, very serious, not that we haven't made a serious commitment, but we step up even more than we have already into much more solar on a utility scale.
I want to say that we need to be careful linking our targets to FPL. FPL has had a rash of unethical practices that have come to light, whether accurate or not. They have enough heft to let's just say change reality. So what we're doing is probably accurate. We have a lot more accountability by the people that can see what's going on, and they have a lot more regulatory capture to put it nicely. So I really want to be careful to say their targets are what we should do, because they have a lot more money behind it. And even if they don't make it past that finish line, they have a lot more money behind it as well.
I think that's true. I think the FPL line comes with significant investment. And for those of us that understand utility rate making, rate-based rate of return, we know that the more aggressive line they put out there, the more capital investment they're going to have to make to achieve it. And they're going to be seeking to put that capital investment into their rate base and earn on it. So it's good for the investor. It's good for the climate. It's good for the environment. It's good for the earth to drive carbon to zero. So I think they're going to keep those aggressive targets out there. I think they're going to drive the target to the limits of the technology, and it's going to challenge the rate makers, the utility commission, to either allow the investment to be recovered or not allow the investment to be recovered. But I predict that I don't see any reason why they couldn't get these levels of investment approved. I think we're long, as a society, we're long past the point now of arguing whether we need to reduce carbon or not. And whether you believe in reducing carbon or not, I think we all want to look up and see clear blue skies. That's one of the things I really love about being in Florida. No matter the time of year, I see beautiful clear blue skies. I want them to stay that way and get even clearer and bluer, and the water too, right? So I don't see people reversing that or easing up. I think that FPL will get the necessary approvals that they need to make those capital investments, and that curve, will come down, and that's what they're going to drive to do. That's my own personal belief. Obviously, I'm not in the boardroom. I don't talk to their executives, but knowing what I know about utility return on invested capital, I think that's what they're going to do.
I agree. My point was just to say that they have the ability to move mountains, whether they actually move mountains or not, I guess is the way to say it. So.
Yep. We've been somewhat fortunate as a municipal utility to be surrounded by the FPL transmission system, which is one of the best transmission systems in the country. And that's really served our community well over the years. And the fact that we're going to have a second interconnection is going to really improve our reliability and our ability to sustain good operations even longer. That's good for the entire community. It also gives us, great ability to import more power as we need it, and export more power, get much more attention to transmission-related operations and maintenance. And it gives us access to, if they do get that curve that low, we'll benefit from that because they're one of the three major suppliers that we'll be able to buy power from into the future.
Agreed. Yeah, they are an excellent operator.
So I guess, I don't know, I sort of just kind of have a question, like this might sound vague, but what are we actually deciding here? Like there's the option of the next 20 years, like where, like the solar, do we choose into that or not? Do we instead come up with a demand-based situation where we have, edge generation, that kind of thing? Like can somebody frame this a little better for me? I'd appreciate that.
So what we're seeking to do as a community is define the resources that we would like to have in our integrated resource plan. So how are we going to meet our capacity and energy obligations into the future? And that's what our friends at Horizon are helping us do. They're helping us to model various scenarios so we can decide which is the best path for us, being conscious of the cost, being conscious of the timing, the demands of the community, and how we're going to solve this problem of getting CO2 out of the environment. So integral to that is not just the demand side. We've been talking a lot about supply, but we have to talk about demand too. So the things that we want to have modeled, and I know that they're working on that as well, is modeling in demand reductions to a demand response system, which would play a role as well. I think it plays a relatively small role, but it's not unimportant. It's an element of the plan. But that's going to help. But the overall goal is to come up with a plan that everybody buys into. That's basically what we're then going to go and act on. So I can make. So if I know nobody's proposing this, but if the group came out of us and said, "Hey, the study shows that the best thing for us to do is build 25 megawatts of things that burn banana leaves," I don't know. Then okay, that we're going to go out and get 25 megawatts of banana leaves, right? But if the group comes out and says, "Hey, we're going to do another 10 megawatts or 25 megawatts of solar," then we're going to go do that. Or we're going to do 3 megawatts of demand response or 12 megawatts of demand response. Okay, we're going to do that. But I think the important thing is to recognize that once that decision is made and we act on it, that's what we're counting on to be delivered. So if let's just say I'm obviously a big solar proponent and we make a decision I'm going to pick some numbers just which I think are directionally correct. Let's say we say, hey, in addition to the 38 megawatts of solar that we already have, go buy another 15 and also build a demand response program for 5. Okay, we're going to go do that. If those projects don't produce those results, well, we got a gap. We got a miss because we will need that capacity. I don't know if the numbers are correct in terms of how much capacity we're going to need, but we'll know how much capacity from this plan we need to ladder into our portfolio. We need to pick early on what they're going to be. And why do we need to pick that early on? Because none of those resources happen at the snap of a finger. They certainly don't happen within one budget cycle. So if we enter into additional power under solar, for example, at a minimum, you're looking at close to 2 years out before it comes online, right? Demand response, probably same. By the time you build a program, get it implemented, get subscribers, get the technology, and get to the point where you can click the mouse and make it happen. So these are not things you say, okay, we made that decision, we'll be online next month. Not necessarily. And then you also have to make sure that it actually comes online, because if it doesn't, you're short of capacity, and being short of capacity can be very, very expensive. So you want to get the plan right, not just in the economics, in the carbon reduction that you're going to get from it, but also in the date that it's going to be available and go commercial with counterparties that are actually going to deliver that result, and they're willing to put liquidated damages on the table if they don't. So we're not proposing to build a steam plant, for example, a gas turbine plant combined cycle, but something like that is probably a 3 to 4 year decision before it's actually in the ground and producing power. And you wouldn't want to find out in year 3 that it can't get built, and now you don't have that resource, right? So these plans are important. And my concern as I look at the history of Lake Worth Beach, at one time they did resource planning, but then it stopped happening for a while. But you just can't stumble through this saying, oh, I need something, I'll go get it. I know it's at the Publix, I'll just go get it tomorrow. Now you have to plan for these things well in advance.
Sure. Okay. Yeah. Great. Thank you. I like that whole explanation. I have a question. So, like, is the second FPL tie line and the retiring of all of like Lake Worth generation equipment, is that built into this plan, or is that kind of something that's happening orthogonally in the background?
No, well, let me clarify first. We're not going to retire all of our generation. We're just talking about retiring steam units at this point. And then
which is half of it, or
that's 35 megawatts of steam would be retired when the second tie line comes online.
so
And then we have
65% of it.
basically then we have a 5-year rolling review of the remaining assets. So that there is, at this moment, there's no plan to simply retire everything right away. Steam units would go at the end of 23. That's been something that's consistent in planning. It's in all of our forward curves for costs. So so that's where that is. Those things are being modeled into the plan already. So the various, and that was the data that you saw early on from Greg. Those are the basic assumptions that go into the model. Then of course they'll model high gas prices, low gas prices, adoption, technology costs, things like that. But for example, if I look at the Stanton unit, there's not going to be a plan that says Stanton runs till 2030, for example. Stanton is going to retire at the end of 25. That's the plan, because the owner has already said that they're retiring it. So we would not come up with a plan that says, no, we want to keep it till 2030. I know nobody's proposing that, but the plan, that's not going to move unless the owner or UC changes the date. And I don't see any indication that they're going to, and we're certainly not lobbying for it at all.
Okay. Yeah, I don't know, going through my head right now, like I'm wondering a little bit about like I know you've said before the current power generating capability of Lake Worth Beach is not enough to actually fulfill the city, but it is used from time to time. I think that's a pretty neat capability, and I like it a lot. And I think we should try to preserve that in the future for, just good reasons. But that ties into a couple of other things, like not necessarily rebuilding a plant, but I believe that it's actually one of the questions that Ramsey emailed in, something about a virtual power plant, grid power on the edge, basically. He provided some articles and other things about it. But just like that, sure, 2 FPL tie lines is good, but that's still, 2 connections to FPL that we now rely on completely and wholly, as opposed to a little bit of an option before. And it just, I don't know, that it seems like a loss of capability more so than a increase into the future.
Well, the best way I can prove that to you is just connect us to the tie line we have and see if we've lost that capability.
No, I believe you on that. Absolutely. I'm not saying we need to be completely self-sufficient. I just like it, the ability to contribute back to the grid in a very meaningful way seems, like something that we should do. I don't know if I'm alone on that, but
from a generation standpoint, I disagree. I mean, to me, you put the assets.
I don't care what shape it forms. The ability, like a virtual power plant, any sort of, solar, virtual, whatever, batteries, but contributing back to the grid seems just as important as consuming from it.
So in like including net metering, is that what you're referring?
Sure, behind the meter, yeah, grid edge.
Okay, so one of the things that we all have to understand is that unlike the internet, power capacity is not in the cloud. It has to be physical, it has to be hard, it has to be reliable, it has to be there. Otherwise, you don't meet your capacity obligation. So we could not go to the Florida Reliability Coordinating Council or the Southeast Reliability Council, or for that matter, FERC or NERC, and say, oh yeah, don't worry, our reserves are in the cloud. They're out there somewhere. Well, it's got to be hard, fixed, identified, under contract firm with very serious contracts. It's not a, hey, gee, if I feel like it today, I'll give you some. No, now you're talking about transmission systems and the integrity of the grid. If you're not willing to do that, you're not in the business. The government will not allow you to be in the business. So it requires firm capacity resources, and the standard here is a 15% reserve requirement at all times. So we have to do that. That doesn't mean we can't do rooftop solar in net metering, not at all. But we have to remember that on a cloudy day, we, meaning you and all of us, have the obligation to serve that load. Whether you plan for it or not, that's not the government's problem. You better be ready to serve the load. You can't say, I'll get it to you tomorrow. It's in the cloud. It's in the mail. No, it's got to be there right now, spinning, ready to go, serve the load. Because lights out is not an option. So that's how important capacity is in these types of discussions. But certainly in the context of a demand response, if we want to clip some peaks through demand response program, and in the future, at some point, for example, vehicle to grid technology, which might give you some energy back from vehicles that are plugged in. That's certainly possible. That is not happening commercially today in the country. Doesn't exist. There are some pilots underway. There are some vehicle manufacturers that say their vehicles will do it, but we have not yet seen a commercial deployment of vehicle chargers that will do that. But that doesn't mean, when we look into the future, I think you're going to see that within a year or two, and within 5 years, I think it's going to be commonplace. So we should accept the fact that that's going to happen.
Yeah, but that would just lower the cost of the or smooth out the demand side, correct? It wouldn't.
I think there's some pilots underway that are going to tell us what it will do. I think there's been pilots that have been talked about. I'm not sure there's any pilots actually underway, but I know there's pilots that have been committed to, and we haven't seen the data from that yet. The biggest one is going to be a few thousand vehicles, I think, in California, are the ones that I'm aware of. But it's either PG&E or Southern Cal Edison. But I think it'll help smooth the curve. How that translates to an economic value, I think that remains to be seen. But there's no reason why the technology shouldn't be able to work. And I believe that very, very bright people will find a way to make it work and have it be commonplace. We want to be able to exploit that technology in the future. So at the moment, we've set it, I think for planning purposes, a number of 5 megawatts of demand response, which could also be supplemented by vehicle to grid. But I would not at the moment do resource planning that says, oh yeah, we're going to have 5 megawatts of vehicle to grid. Based on what?
Yeah, and you wouldn't know how many vehicles are plugged in at any certain point, and yeah, it's too transient of a source to rely on.
Yeah, for example, I don't envision a scenario right now where the most practical vehicle, for example, is probably the F-150 Lightning, right? Where 50 contractors sell it. Hey, listen, I got to get home by 4 o'clock. I got to plug in my truck in and sell grid to power to the grid. How do I know they're going to actually be home to reverse power back to the grid when I hit my peak between 4 and 5 o'clock, or again at 7 o'clock? Yeah, we'll have to have some probability that says, they're going to be there. Will they be there over time? Absolutely. I think they'll be there by the hundreds. I think if we're sitting here having this conversation 5 years from now, we're going to say, wow, look at how much the marketplace changed. But what number should we assume right now if the technology hasn't been proven commercially yet? That's a hard one.
So I mean, that brings, I mean, we've seen the projections for, the supply side of CO2. What about the demand side within the city? What are we looking at there? Is that ready for us today, or is that another presentation?
Well, we'll take a look and see what's in the modeling, but we've put a stake in the sand and said, let's assume 5 megawatts. If somebody thinks the number is higher, well, let's make it higher. I think I explained how I came up with the 5 megawatts.
Yeah, no, that wasn't my question. My question was, as the city progresses on in this 20-year timeline, for example, do we see growth in demand in the city, or do we see it staying the same, or do we see it dropping from what we're currently? I think you said around 60 megawatts is roughly what we're doing right now.
Definitely going to grow.
Okay,
yeah, so
that was my question.
Yeah, let me give you the history on that. Our most recent peak that was set in 2019, and then we tied it again about 3 weeks ago, is 97.2. So our peaks, I believe, and I may be wrong, but if you go back into the, prior to 2012 timeframe, back in the early 2000s, I think our peaks may have been higher than they are today. I think that's the case. I'd have to go back and look at old data to see that. But we got to 97.2 in 2019, and we tied that again a few weeks ago. The rate of growth of the peak has not been evident at all. What we have seen is growth in total megawatt hours or total kilowatt hours, if you will, that have been sent out to customers. So that is growing. For planning purposes, we use a number of 0.5% per year growth in the amount of energy that we send out to our customers. Most recently, I believe last year, we actually saw a little bit over 1% over the prior year. On a year-to-date basis, I believe we're running around 2.3% growth over the prior year, although the peak is not really growing. So the good news in that is we're getting better utilization of our assets because we're not having to build, more capacity in our transmission or distribution system necessarily. The capacity that we're building is for reliability, not for the ability to increase the send out. But our load growth is growing.
Just
to
rephrase that real quick. I'm sorry.
What's that?
Just to rephrase that real quick, you're saying our capacity has remained relatively stagnant, but the total energy consumed has been growing at a rate of around 3% for the past few years?
No, it's well under 3%. We plan around 0.5%.
Oh,
Although the last 2 years, meaning in fiscal or calendar 21, and I can go up and pull up the actual numbers. I've got them on my spreadsheets here, what we actually grew in 21. And year to date in 22, we're through the end of July, we were 2.3% higher than the same period in the prior year. Not 3%.
I think it's safe to say that 2020 and 2021 can be an anomalous 2 years.
Correct.
So
But still,
you might see that reverse or flatten out over the next 2 years if it,
yeah, just
It's-
more people were at home, but also commercial places were shut down. It's hard to draw any conclusions from that, but I mean, is that same kind of trend visible over the last, say, decade of energy remaining or energy kind of going up and then peak capacity remaining relatively stagnant?
Is somewhat so. I'm going to pull up some data on my spreadsheets while we're talking to give you more accurate answers. But that's generally been the case. That the peak had grew a little bit. And again, it got to 97.2 in 19, and then it stopped right there. And then it actually dropped. And then in 2022 in July, it hit 97.2 again. I don't know where we closed out today. At about 4:15 this afternoon, 4:10 this afternoon, we were, I think, at 96.5 or 96.6. Brian, I don't know if you got a current number at the end of the day, but that's roughly where we're at. So
Roughly correct. Yep.
Yeah, my AC was running. It was contributing.
I think all of ours were.
Yeah.
Hey, I was going to ask at some point, we should probably read into the record our board member Ramsey Stevens' questions, just so we get them out there and you can watch the recording and get the answers. Would now be a good time for that?
I can give you those peak numbers right now if you want. I can read some numbers to you real quick before we switch subject. Got them here. There's my historical spreadsheet. Okay. So for the period of 2014 through 2021, our average growth was 1.43%. But there's some anomalies in there because in 2014, we grew at 6.95%. And in 2016, we grew at 4.27%. And then in 2017, we actually went down by 2%. But in 2017, we had Hurricane Irma, which knocked us out for about a week. So if we just look at the recent, let's say 4 years, the recent 4 years, we grew at an average of 0.31%.
For total energy consumed.
Total energy consumed by our customers.
Okay.
And I say by our customers, and I mean that taking into account that during that time, net metering grew from, in 2009, from 0 customers to about 170 customers by the end of 2021. And they comprised about 1.5% of our system peak. We don't know how much energy they produce because we don't meter their production, but they're 1.5% of the system peak right now. And growing rapidly. Our peak, and for some reason, where's my peak numbers here? Our peak since 2013 has averaged 94.3. So back in 2013, we were 87.4, and then we grew, 1 to 2 to 3, 4 megawatts per year until we peaked in 2019 at 97.2. Then we dropped to 96.7 in 20, 95.7 in 21, and in 22, the July number, I believe, was up to 97.2 again. So the peak really is not growing, but the total amount of energy that we send out is, which is somewhat intuitive because it's, customers just organically, as they replace appliances, are replacing them with more efficient appliances. As people renovate homes, they put in more efficient windows, they put more insulation in, a better air conditioner, better refrigerator. So long as they don't keep the old refrigerator and put it in the garage, they're actually using less energy. It's hard to find a home that's still running on incandescent bulbs or old fat T12s, but more and more people are on the CFLs and the LEDs. So the peak isn't growing, but the total send out is going. I think what we also see is that as appliances really became more common, more washing machines, more dryers, more air conditioning in homes that perhaps couldn't afford it in the past, you see more appliances coming into homes that may not have had them before. I think that's adding to the total send out. We have had customer growth. We've been growing nicely on our customer count. Usually we plan about 0.5%, but recently we've been growing a little bit more. Energy use or megawatt hour per degree day has not really moved. So we think that there's more conservation happening out there under the surface. So we track degree days, and we do track megawatt hours per degree day, and we don't see a lot of movement in that. For example, in 2013, we were using 95.26 megawatt hours per degree day. And in 2021, we were using 95.88. So we went from 95.26 to 95.88 megawatt hours per degree day. And over that period of time, degree days had grown by 1.4% over that period of time. So that's just the, we don't see huge growth in megawatt hour per degree day. We don't see huge growth in peak coming, but we are seeing significant growth in total send out. And I think the growth in send out is likely to continue for a little bit. We do have the Bohemian coming online.
I was just about to ask about that. Yeah, I was going to say, what's the average impact of something like that coming online in terms of kilowatt or maybe even megawatt hours per day kind of thing?
Well, the Bohemian, we don't know the numbers exactly, but we can extrapolate based on what we see at the mid. The same developer, basically same design box, concrete with insulation, impact glass, better windows, right, with film on them, and they're probably I'm guessing a 15 to 17 SEER air conditioner in each unit and LEDs. So that usage is substantially low. I don't have the exact numbers, but they hit our targets in terms of what the revenue generation, but they're substantially more efficient than the same square footage cottage, for example. Obviously, because they're
of course,
they're built for efficiency to modern day code, right? So they use a lot less energy per square foot than an older home. I don't have the exact comparisons, but it's just intuitive that they would. The cost,
multifamily is more efficient as well. So
it is. You have less roof area. Now, maybe the rooms in the apartments in the top floor may be using more energy than the ones on an inside unit in the middle floor. that faces east versus one that faces west, and that type of stuff. So, but generally speaking, they're very, very efficient. I think the bigger value is the 200 additional people that are shopping and enjoying the downtown and enjoying the amenities that the city brings, and the trickle down in our commercial businesses. But they're certainly helpful to the electric utility.
Cool. Okay.
And again, we haven't seen them really pushing the peaks up. I think what we don't know yet is the story on the electric vehicles. I think obviously we see more and more electric vehicles in town. We have our public stations. You see more driving around. I got to believe that more and more residents are buying them. And that's not going to stop. That's going to continue, which is good. I think electrification of mobility it is and traction is good.
Okay, good. Thank you. I think that was a big digression at my request, and I appreciate it. But I do think Ryan had a question at the same time, or maybe it was Matt. I'm not sure.
No, my question was basically to read into the record Ramsey's questions that he submitted ahead of time that he couldn't be here today to read out loud and ask himself. So I guess I can go ahead and take care of those. This would be questions for Horizons Energy. Question number 1, is Horizons Energy able to model the value of a virtual power plant for our community? Is this something we should pursue beyond or as part of our prospective demand response program?
So are you looking for a response from Horizons for that?
Well, it's a question I'm putting out.
Just real quickly, what our models do is to identify, we put different resources, the different reasonable resources that are available to the city over the forecast horizon and identify those that are the most economic over that forecast horizon, given all the things that we talked about, demand and existing resources and any environmental constraints and the cost of fuel and other things. So it's a big fundamental supply demand transmission model. So can we model a virtual power plant for the community? The short answer is yes, but we would require somebody else to identify for us things like what would, if there's going to be some kind of mix of resources in that virtual power plant, we need some indications for those. We know sizing, we know costs, we know generating characteristics, but we need some guidance as to what would go into that plant. And then we would need some indication, if that's to be pursued, what, if any, incentives would be provided by the city, either through some sort of net metering rate or some other compensation, such as I think that small Vermont utility article, it implicitly has something that's maintained by that utility. It's basically a subsidy for acquisition of a storage technology. So we would need to know the what and wherewithal with regard to how that would work. We would. That's another what should be done rather than what is the optimal decision or resource plan under some set of conditions. So
we would, or what Horizons would need is, okay, so how much of these things do you want to add? And what do you think they're going to cost? What do you think you're going to offer people? And so you want a megawatt, 2 megawatts, 60 megawatts? Sure, they can be modeled. But all of the resources that they model it, they know what they cost to operate, they know what they cost to build, and you can figure out, well, this is where it might fit in your portfolio. But so you obviously need more data before you can model it, right?
And that's the other implicit thing that I didn't say is, yeah, at a certain, what's the level of penetration? So if you do have some scheme for incentivizing or providing through rates or something else, what's the customer response? And that's a marketing or a research element that that we would use as an input to our models.
Gotcha. All right, thank you. Second question, does Horizons Energy see any value in determining the floor price at which we, worst case, would need to sell excess solar power in the open market? If we knew the floor price for surplus solar power, couldn't we then examine establishing a rate class that encourages as much community-based generation as possible without adversely impacting the utility's economics? The notes say, I understand power prices can go negative in certain markets, so this is a potentially very risky proposition if a dynamic price isn't possible. And then lastly, alternatively, does Horizons have any other thoughts on rate designs we could adopt to expressly encourage our community members investing in more low cost to no cost generation for the utility in a profitable way?
So I'll have to answer this question. So yes, we can answer this question. The answer to the first part of the question is, would we need, I think that what the gist of the question is getting at is to being able to provide additional services to participants in certain kind of programs, solar, or, I mean, it sounds like solar, but it could be solar or storage or some combination thereof, in which participants could receive some level of compensation, either as a credit or some other mechanism. And then on the other side, the non-participants would not necessarily see their rates go up. So this is another area that we don't specifically do. Rate design is an area that we actually work with other consulting firms if we're going to do this kind of thing. The one thing I would say is that, I mean, the viability of this thing depends on the effectiveness of that rate design program, and it's a difficult thing to do. California's in their third round. They call it 3.0, net metering 3.0. It sounds like it should be somewhat easy, but it's a difficult thing to administer because you're chasing either overcompensating or undercompensating participants, potentially to the detriment of the non-participants. So it's a difficult question. It's in terms of rate designs, we don't opine on rate designs per se. We tend to provide resource plans and give guidance on near-term action plans and things like that.
So I'll add to that and say that our rates consultants, a company called Leidos, they do our rate design for our commercial and residential rates, and we don't have an industrial rate because we don't have an industrial customer. But the state's laws on buying and selling power, if my understanding, restrict us to paying for power at what's called the avoided rate. So, and our solar customers today, for the amount of kilowatt hours that they overproduce, and Ryan, I don't know if you overproduce, but you're probably familiar with this. If you overproduce over the course of the year, meaning you've sent more power to the utility than you've actually used, so you're a net exporter, you get paid for your overproduction at the avoided rate. And we calculate the avoided rate and we publish it, and we actually issue checks back to probably maybe 10 to 20% of our net meter customers get a small check back for that.
Yeah, my check was about 13 cents last year.
How much?
13 cents. It cost more to put the stamp on the envelope than the check was for overproduction.
That means you right-sized your system. You nailed it right on the head. So that was good. So,
okay.
But I think the question here is really with regards to when you look at the avoided rate and say, well, what do we think the avoided energy rate, or we call it sometimes system lambda, or the dispatch rate? What is the market cost to make power, wholesale power at any hour of the day? That's a very difficult number to extract. That's not published in Florida. There's no real-time price. We know what we pay, but the contract we have now may not be the same contract we have 2 years from now. So that's a hard one, but you can generally back into it. I know Commissioner McBoy's on the line and listening. We talked about this, but if you assume, for example, a very efficient combined cycle at 7,000 BTU per kilowatt hour, and you assume a $5 gas price, you come up with 3.5 cents per kilowatt hour is what power probably sell for on the market if you have $5 gas and an embedded fleet of 7,000 megawatt or 7,000 BTU units. Now I'm just thinking that FPL's more efficient units are probably running at 7,000 BTU per kilowatt hour, 7,500 to 6,500 in that range. Well, let's say that their fleet average is 9,000. And they're they're the big player in the market, right? So they're probably driving the market price. You're looking at it at a 9,000 heat rate times $5 gas, you're looking at $4.50. That's what the energy's worth. We can't credit customers back for the cost of the distribution infrastructure they use, because they didn't make distribution infrastructure for us, right? They just avoided an energy cost for us. So I think that's what he's getting to, Greg, is what might that system rate be? And I think it's highly dependent on what you think natural gas prices are going to be in the future. Natural gas is really driving the marginal price in Florida.
I think maybe, I can't speak for Ramsey particularly, but it's sort of along the lines of what, this is Commissioner McVoy, along the lines of what Ed and I and the city manager were talking about the other day. The idea of trying to figure out how much solar capacity you want, or solar generation you want to take on, is messy because it's a variable energy source. It does different things in the middle of the day than it does in the ends of the day. It does nothing at night. It does different things at different times of the year. It does different things when the clouds shine. So all of that would suggest that you might want to oversize your field so that you've more of the time are operating off of solar. But if you're going to do that, you also want to know, can I shed some of that I don't need? If I've oversized my fields, can I sell power to somebody else? And if so, what would the price need to be to make it economically viable to go higher in your sizing your field? I think that's probably the kind of direction that he was thinking of, because if we knew that we could unload power extra, then letting people size the rooftop a little higher, buying larger solar field PPAs, there are a number of things that would influence.
So I
do agree. I think that was the question.
Yeah,
just from interpreting it.
Just to get everybody in, the commissioner and I shared a conversation just yesterday. We talked about this. So, for example, the thinking is that, and I do believe this, that we can overproduce. That's been part of our strategy. Because if you look at FMPA Solar 1 and Solar 2, we're going to be overproducing slightly, and I'm proposing that we do that even more so with FMPA Solar 3. That we're going to be overproducing during certain parts of the year, certain times of the year. However, when I look at the amount of energy the state of Florida needs, I'm confident that we could sell that power back to somebody else in the grid. Now, I'm not saying that we'll always get back what we paid for it, but I feel pretty good saying that if gas prices stay above $5 or $6 per million BTU, that when we look at the price of power that we can get from the FMPA Solar 3 projects as a proxy, which is roughly $40 per megawatt hour or less. The published number is 40 or less. I can't disclose the actual number. I'd say I'm okay with that. I think that we can sell that power in the market, because I think it's highly unlikely that the gas prices are going to go long-term below that $5 number. And even if it does, I'm not going to lose all of our money, right? We're going to take a little bit of a bite, but during the months of the year when we can use all of it, we'll be really glad we have it, right? It'll be a great physical hedge against gas prices. Now, gas prices today were in the $9 to $10 range. I know Brian's on the phone. Brian, do you know offhand what the market price of gas was just today for generation?
Yeah, it was just over $12.
Right. So I feel pretty confident, and obviously I don't want to say what the future is going to do based on what it did today, but we're expecting to stay over $9 for gas into the spring. So more solar will serve as a physical hedge against higher gas prices in the future. But that's solar that we own for all of our customers that we build very, very cheaply. Now, if you're a residential customer, you're not going to be able to produce solar power for under 4 cents a kilowatt hour. Now, if you want to build your system and go do that, knock yourself out. But I don't think you're going to be able to make money at that price. To get those types of economics, you have to build very, very large projects, 75 megawatts, 150 megawatts, 300 megawatts at a time, get tremendous economies of scale to do that. It's just not going to work. So
I have a question.
Yeah, go ahead, Matt.
Director Liberty, you mentioned that the FMPA or FMPP, I think we're using those interchangeably, correct?
Well, FMPA is the Florida Municipal Power Agency, and all of their generation assets are in the Florida Municipal Power Pool. They're them with a bunch of other large municipal utilities make up the pool, but they're probably the biggest.
Correct. Yeah. So you said that their model of dispatch is based on the economic model. The cheapest stuff comes on first.
Correct.
Is there any way we could lobby or just inquire that they move to a carbon-based model? Because to me, if we're really looking at the future and we want to get them to, I mean, and right now, if natural gas is 12 and they're producing at $40 a megawatt hour, it sounds like the lowest carbon option is the cheapest right now. Is there any way we can ask them that they kind of start shifting to a model that's carbon based rather than economic based?
You can ask them, but they're not going to.
They're not going to. Okay.
No, they're driven by the economics of the member city. So just because one city said, "Hey, we're very progressive, we believe strongly, we think you should change your whole dispatch model to a carbon-based dispatch model," yeah, I don't think they're going to do that. They're not going to. They're not all. I'm not saying it's good or bad, but I don't think that would get a lot of audience with them. Now, if there are carbon tax and other penalties or economic motivators, absolutely, they're going to follow the economics. But they've got to keep the lights on, and keep in mind that, and I say keep in mind, most people are not familiar with this, but these are very large units in the hundreds of megawatts that you just can't start them up. Oh, I need it now for you can run it this afternoon for 2 hours. Oh,
yeah, sure.
I don't think so. How about if I start it up on Sunday and I promise to try to keep it running until next Sunday? I may cycle it a little bit in the evening, but I'm not going to shut it off until it's not a light switch. So they're also trying to maintain their obligation to the grid to maintain the stability of the grid, frequency, voltage, spinning reserve, reserve margins, things like that. If the unit's not running, it's not providing spinning reserve. So let's explain what spinning reserve is, because I used that thing a few times. So spinning reserve means if you're operating a system or a fleet, you have to be able to absorb the loss of your highest unit from a stuff that's already spinning, right? So let's assume for a moment you have a 1,000 megawatt unit on your system, and you have a 10,000 megawatt system. And I'm exaggerating numbers here just for the sake of math, but this is the environment that I came from. So you've got a 10,000 megawatt system, you got a 1,000 megawatt unit, i.e. a nuclear unit. You have to have all your other units running at part load to be able to make up that 1,000 megawatts. If it disappears instantly, it trips. So you have to make up that 1,000 megawatts within a typically 30-minute period of time. Greg, are you using 30-minute scenarios or 20-minute scenarios in your modeling for the IOU?
It really depends on the area, but in Florida, I think it's 30 minutes.
Right. So really what forces you to do is you have to have very, very quick, very, very reliable peaking turbines that could start up and have up to speed producing power within 30 minutes. Or you have to have a whole bunch of other stuff that's running at part load to make up that 1,000 because it's already spinning. So that's called spinning reserve, right? Mm-hmm. So they would probably not say, well, we're going to switch our system to operate based on, we're going to operate all the solar first and take and retire all the plants or shut them down, and we'll call the operators if we need them. When the solar is an instantaneous on or instantaneous off resource, it varies with cloud cover dramatically. We have examples, our own units, for example, just looking at the output, how much the megawatts just swing within 10 or 15 minute period of time, let alone a 5-minute period of time. We can swing as much as half a megawatt, 3/4 of a megawatt, a megawatt easily in a 10 to 15 minute period of time in our unit, just one solar unit. So imagine what we're going to be looking at when we have 38 megawatts of solar. Now we're not all under the same cloud. We've got them dispersed around the various locations, but the load's going to swing significantly. It's going to put a big premium on spinning reserve. We as a city have a substantial hit or swinging load already because we've got our 1.7 megawatts of solar that's swinging with cloud cover at the same time that our customers' 1.5 megawatts roughly of net metered is swinging up and down. So we've got 3+ megawatts of our load that could swing a megawatt easily up and down within minutes on our system.
Okay.
There's a lot of spinning reserve that we're paying for that's embedded in our transmission rates. And I believe that what's going to happen over time is the transmission owners, i.e. FPL, Duke, TECO, are going to be charging a lot more for what's called an ancillary service, which is spinning reserve, voltage regulation, VARs, things like that. So those are coming in our rates.
Okay.
That doesn't mean we shouldn't do more solar, by the way. It just
Is
means
a
the cost
is a potential mitigation or solution to that some sort of either like battery system, just either at the grid level on top of it or at the edge level behind the meter?
Well, there absolutely is, and that's what Greg and his company are now modeling in the highly deregulated markets, where these things that were previously provided for free by the utilities are now revenue generating sources for independent power generators, right, Greg?
Right. It's a menu of ancillary services. Some of them you mentioned, regulation and spinning, and then there's other flavors such as supplemental, frequency response. And batteries are playing a big role, especially in the shorter time frame services.
So in those very competitive open markets, deregulated states, those services are starting to appear to be economic, and our investors are willing to put their money into it. But that market doesn't exist in Florida. I believe it will exist. I don't think we'll be deregulated anytime soon, but I think that the big transmission owners are going to begin to put a premium on those services that they've been providing for free. So we've been a free rider to some extent. Now we do have a very strict load factor numbers that we have to operate within. We're looking at the difference between real power and actual power, reactive power, but now we're getting into transmission electric theory, but we do pay for that. And I think those expenses are going to increase in the future. So we are building into our substations, certainly into our main yard and canal, capacitor banks, which help with that problem as well. So in small amounts, a capacitor bank is a better way to do it than necessarily adding batteries. But batteries will certainly be a part of that in the future.
Okay, yeah. It almost sounded like you were saying batteries negatively impact like power factor. I don't know anything about that. Is that?
No, I think they can help in power factor, right, Greg?
Oh,
Yes.
okay.
Yep.
Great. Okay.
But I think they're more expensive than capacitor banks.
Yes.
Okay. All right. And then capacitor banks, those are what we could have, but those do negatively impact, or no, those positively impact power factor.
They positively impact. As a matter of fact, we're installing capacitor banks to improve our capacity factor or our load factor, so that we can remain in compliance with the transmission system requirements. So FPL wants us within a certain bandwidth on capacity factor or load factor, really.
Okay.
And that's a dynamic device. It's continually adjusting. Typically, you see in your neighborhood, you might see capacitor banks on poles, which are used not necessarily for capacity factor, used to prevent sags and swells on voltage. So we might use them more in the summertime when voltage might sag a little bit more load. We might take them out of service in the wintertime when we have adequate voltage. We're typically looking at voltage at the end of the line. We want to maintain voltage on those distribution feeders and circuits.
Gotcha. But the whole switch to 26 kilovolt lines or 24 kilovolt lines, whatever we're doing ought to help with that too, quite a bit.
Yeah, it is helping with that, and we're putting voltage regulation at the substation, and we're adding by phase, and then we're adding capacitor banks at the main yard to take care of correcting our power factor with the transmission system.
Commissioner McBoy, did you have a comment? Because I saw you had your hand up when Matt was asking this question.
I might have. The thing that I was thinking about, and I lost it right as you asked it. And I guess it's coming back. One of the ways possibly to think about how do we want to set our goals for the next 20, 30, 40 years, is to think about it not necessarily from the angle directly of carbon reduction, although I think all of us have a definite interest in that. But another way to approach it is to think about it from stability of pricing or hedging against variable fuel costs from the consumer end. Are there things that we can do, and are there things that we can model specifically that would give stability to people buying the power over long periods, over a year, over 5 years, 10 years? And can that be a way to guide our planning? It's sort of a little bit like, I don't remember whether it was Matt or Eric that asked, could you get FMPA or FMEA to dispatch based on carbon rather than in cost? Similar sort of idea that if you focused on, hey, I want to hedge the prices for the consumers, what would I do to do that? Well, obviously solar panels give stable prices over at least a 20, 25, 30 years time span. So you might get to the same point of increasing your renewables and decreasing your carbon, but you're coming at it from a different angle. Is that something that can be modeled at all?
So in general, yes. Any resource mix has an implicit set of embedded optionality and inherent risks. So your solar has the weather risk that we've talked about. It may be more vulnerable to certain kinds of events like a hurricane or something like that. Natural gas, as we're pointing out, is a very volatile, and especially volatile this year, price. So you're exposed to a market price. So there's two. So if you're talking about risk mitigation, there's two general things, of course. You can either invest in physical risk mitigation. So you're suggesting the solar is a physical risk mitigator, and then you can also invest in financial risk mitigation, where somebody will provide a payoff if a certain event occurs. So when we do this kind of, in order to do hedging, it's actually, or a risk analysis, that's something that's generally layered on top of scenario-based analysis. We've talked mostly about scenario-based analysis to this point, but yes, we can perform also. And the risk analysis takes the form of strategies, and you start to define what your level of risk aversity is with regard to either total system costs or your level of exposure to something in the market. So that's an additional exercise to what we've talked about today.
And to further add to what Greg was saying, so when we conduct our analysis to determine the optimal plan, one, the Encompass planning model is solving to determine which program is going to provide you with the least cost plan. So it's going to provide you with the one that's going to decrease or increase revenues the least. In addition to that, because we are running with that carbon target for Lake Worth Beach, then it's also going to ensure that it's meeting that least cost and meeting that carbon limit. So I think, was it Eric, you were saying, well, could we dispatch against carbon? Well, that's basically what the Encompass planning model's doing when we're doing the portfolios and looking at your expansion plan, is we're dispatching against an hourly energy price that would reflect what the outside market is that you could either buy or sell your surplus into. And then we're also looking at you meeting that requirement. We could probably also put that a separate requirement on the external market as well, so that both of you. But then, as Greg said, we're doing the 9 scenarios. So that's going to give you exposure to high natural gas prices and what the expansion plan is for that, or low natural gas prices, which is going to put downward pressure on the solar existence in your portfolio, as well as then we're doing, a US carbon tax. So in that instance, you're definitely going to reflect dispatching against a carbon price. So I think that all the things we've discussed will be covered in the analysis by utilizing Encompass.
So for example, let's talk about solar then for a second. So we did FMPA Solar 1 and Solar 2 combined for 36.5 megawatts. And we already had the 1.7 that the city committed to back in 2016 and 2015 timeframe. So it's not so much the megawatts of capacity that we include. Certainly capacity in solar has some value, not as much as you think, but some. But there's the energy component. And off the top of my head, I'm just picking an easy number. Let's say that 36.5 megawatts might give us, I don't know what the actual megawatt hours. Let's assume for a moment it's 100,000 megawatt hours a year. We've made a conscious decision to not buy those 100,000 megawatt hours from natural gas fired plants. So as that load comes on, as that power comes on from solar, it's going to displace directly the power that we would have bought under our supplemental agreements from gas-fired plants. It's going to shift. I don't know the 100,000 is exactly correct, but we've made that decision that regardless of the economics, we made that decision in 2019. We said we want that solar in our portfolio. So that's what we want. Now, in hindsight, that looks like a very, very good decision because you can't buy power at that price again today.
And I think that's sort of where I'm going a little bit is exactly what you're saying, Ed, that by having the solar, you're obviously buying less of the gas, and the solar price is a lot more stable than the gas price is. And the tax or carbon tax or various other regulatory aspects are going to even skew that further in favor of the solar, because there may be benefits to the solar, there may be increased carbon taxes of one another variety. And it would be nice to see for customers, hey, as we move to this, not only does this lower our price, it lowers our exposure to variability, and that has a benefit to consumers. Absolutely.
It's a great physical hedge, and just part of this strategy that I brought to the table together with these folks back in 2018 and 2019. And that's why we're looking very hard at FMPA Solar 3, especially at under $40 a megawatt hour.
The more battery, the more, and it doesn't have to be battery storage, but storage, whether it's directly battery or whether it's the indirect, something like using the solar to produce hydrogen and then feeding that back into turbines, that certainly makes a solar field start to look more like a spinning generation and much more easy to deal with. The further we get along in the back storage technology, the less you care about whether a cloud goes by or not.
Yeah, I think FPL, to their credit, on the backs of the FPL rate payments, is going to demonstrate whether the hydrogen blending in the turbines is really working. But I don't want to suppose for one moment that blending hydrogen into our turbines would be possible, but we just don't have the hydrogen capability, and nor do we know if these turbines could be retrofitted to burn any form of hydrogen. They were not designed anywhere near run at those types of temperatures. But
we wanted cars, that's a little bit like me trying to put it in an old lawnmower engine in the backyard. Probably not a good plan.
It might work for a few minutes.
Yeah, until it doesn't.
Commissioner, your lawnmower engine is much newer than those generation units.
So I have a have a question, or not really a question, but on the heels of that conversation, I'd just like to throw out kind of a straw man sort of. So say we go all in on buying as much solar as we can generated from whatever sources. And we also go all in on solar everywhere, like on individual homes. And then we buy a bunch of batteries and put them somewhere where they operate at the utility level. Like what's wrong with that plan? As many batteries as feasible, like as much solar as feasible. What goes wrong there? Like what are our downsides? And that's an open question. I don't know them. That's why the straw man.
Yeah. So, not necessarily the first problem, but one of the problems you have is that you're not going to have enough capacity. The solar at best is going to have 30 to 50% capacity value, because you can't count it every day. It's a variable resource subject to the whims of Mother Nature in terms of whether it's going to be sunny or not. It could be cloudy for 2, 3, 4 days in a row, so it compromises not only the production that day, but also the ability to recharge the battery. So that's one of the concerns with going all solar. Also with batteries, unless at the moment under the current tax laws, as I understand them, unless the battery is constructed at the same time and at the same location as the solar field, the battery would not get the investment tax credit, which makes the battery very, very even more expensive than it already is. Batteries are not economic today in Florida, they're marginally economic. You see them happening at FPL because the Public Service Commission said to FPL, go ahead and build it, charge the customers for it, it'll work out in the long run, we'll let you earn on it. And they also believe it's if you don't start playing with them, the cost will never come down and you'll never learn how to fully use them and tweak them and refine them. So I think that the batteries you're seeing today are going to be substantially different than the battery you see 5 years from now, 10 years from now, 15 years from now. But if you don't buy a battery today at the scale that FPL is doing it, you're not going to have that really good battery 15 years from now. So they're taking a very important first step.
If I can just jump in, there's another point to be made with regard to reserving as much capacity as needed and the length of contract. You get into a question of optionality. You give up some of if you lock in a lot of long-term contracts for all known resource needs today, as opposed to taking shorter-term contracts, you give up the optionality of what if technology improves or what if something else happens. I don't have an option that I can then do something differently in the future if I've locked in my forward resource needs.
Of course, diversification is the answer. And again, the only point of the straw man is to hear the downsides in order to determine, how that diversification number should look in terms of the integrated resource plan. So like, if there was more that you wanted to say, Ed, please do continue.
So I was going to go down that diversification path. So let's say that the folks who sat on these Zoom calls or whatever took place in Zoom back in 1986 said, instead of 22 megawatts of St. Lucie, we want 62 megawatts of St. Lucie, which will produce the 470 some odd thousand megawatt hours we'll need one day. We have it all in St. Lucie.
Is that an option?
Back then it might have been. It's not today. But
I wish it was. Okay.
But,
all right.
Well, but maybe not. Right at the moment, it looks good, but who knows where gas prices? So, but there was plenty of time in the past where people said that's a very expensive unit. It all in, that unit's around a $52 a unit, $56 a unit today. But there were, that was as much as a $60 to $70 unit for a while, 70 plus, right, Brian? So there were times when you said, boy, that's a very expensive unit, $70 all in. So the point is that as good as it looks today, and you wish you had more, back then people said, my gosh, why did we take so much, right? And I think that gets to what Greg is talking about. If you take a lot of one thing, as good as it looks right now, you lose that optionality down the road in case something better comes up. But I do think, and we'll see where the modeling takes us, but my gut is telling me if we go another 10, 15, 20 megawatts in FMPA Solar 3, that we will not have oversubscribed, that we'll still have room in the portfolio to do other things. Yes, we will be selling power into the grid.
But as you've mentioned, and I was just going to say that the selling option makes a big difference to whether, how far oversubscribed you are. If you have the option to move it out, then,
And also, one of the things that we did with St. Lucie, and I mean, I'd say it's overlooked, but not everybody follows this level of detail. We've now refinanced a couple of times. So as interest rates came down, we refinanced. Not we personally didn't do it, but we, as a part of FMPA, undertook a refinancing, which dropped our costs from solar. I'm sorry, from St. Lucie by about $2.5 million a year. Just that refinancing that we got done in the last 12 months. So that was a very, very welcome reduction, and we're benefiting from that tremendously. We're the biggest player in the St. Lucie project with all of the FMPA participants. So much so that we actually drive the bond rating on FMPA's investment on that project. So there's a lot of other cities that wish they had our piece of St. Lucie right now. And
That's
gas,
awesome.
$10 and $12, especially at the refinance number, which got us down to about $52 per megawatt hour.
If only we had more.
For today.
But we have to be diversified. And in other words, you would not want all of your solar on the same mountaintop. For example, when the cloud comes over, you just lost all your solar. And so let's talk about that. When we nominate capacity, we nominate under our supplemental contract with our supplier, whether it's OUC or whoever it might be in the future. If we've nominated our resources and our resources don't produce, we don't have capacity that day. We literally don't have capacity that day. That's our problem. It's not their obligation beyond a certain amount to go. They can't build something in a day. They're only going to deliver to us what we asked for. So if we didn't ask for it, they're not going to deliver it. If we said, hey, we're going to get 36 megawatts of solar, and let's assume that we're only going to take capacity for half of that. So let's say it's 18 megawatts. We're going to nominate 18 megawatts of capacity. And let's say, for example, it's really cloudy. We don't get the 18 megawatts. Well, they weren't planning on producing those 18 for us. They may not have it. So, and if they do have it, it's going to be very expensive. So when you do the capacity planning, you have to get it right.
But isn't it fair? And this would be a question both for Ed and Greg. Greg mentioned earlier that there is in the deregulated markets, there's a growing sort of, let's call it a cottage industry. They're big cottages of people who say, hey, I've got a big battery bank and you need to be able to get up to speed in 30 minutes. And that's worth a lot. And we know your turbines aren't that nimble. So we're going to build a battery bank that's going to fill in. We're going to charge you for it. But I would think as the market is and as the industry is changing from a mentality of very steady sources, something that's spinning and has a lot of inertia and achieves its stability that way, to dealing with very variable sources, whether it's wind or solar, the market will start to fill in those storage options, the capacitor that evens things out. Whether it does financially. Let me scare
you now with a little bit of reality. So let's go back to fall of 2017. Our capacity contract with OUC said our combined cycle will have 90% or better availability. We guaranteed it. In our capacity contract, to buy capacity from them, we guaranteed them that our unit would be available 90% of the time or better. In 2017, it didn't do that. Brian, what were our penalties for not meeting that capacity obligation?
I believe it was $3.5 million in penalties.
We paid $3.5 million. The actual penalty was about $4.25 million. When we renegotiated the contract, OUC waived 1/4 of the penalty. We paid $3.5 million in penalties. And you say, wait a second, we paid the penalty? Yeah. If you promise somebody capacity, you're going to bet on capacity. You're not just going to get the value of the capacity when you want it. You're going to pay a penalty if you don't produce it. So it comes with a big penalty. So it's not necessarily a free ride. There's a flip side of that too. When you sign a capacity contract with somebody, if they don't produce that capacity, they pay a penalty, liquidated damages. And we paid those $3.5 million in supplemental penalties. That's not unusual. What was unusual is that the city had entered into such a contract, which was done back in 2013. So that capacity is serious business. If you're short on capacity, the penalties can be huge. to the person, because you're asking for a short-term emergency buy on capacity. And you're at the whim of the market at that point.
And also, Ed, you don't have reservations on transmission. If you don't buy that capacity and you're short, OUC could have the energy, the electrons to send us, even though we didn't buy capacity for those particular megawatts. They may have electrons available to send us, but there's no transmission reserved, and the transmission is packed. You're not getting it down here. So they may have it, but they can't send it to us. So if you don't reserve that capacity, you are in a predicament.
So let's go through that detail, because that's very, very important what Brian said and it hasn't been discussed. So let's just use some simple round numbers. Let's say we predict that we need 75 megawatts of capacity for the month. And we say, hey, the first 25 we're going to produce ourselves. We want you to produce 50 for us. Right? In this case, OUC will say, okay, we'll get you 50. They'll line up their fleet to give us 50, and they'll reserve the transmission, right? The seat on the plane, if you will, to get it from there to here. Now they've got transmission booked for 50. Now let's say our load is actually 65, and they'll say, hey, Ed, your load is 65. You only nominated 50. You got to get the other 15. And I'll say, well, can't you make the extra 15 for me? Well, maybe I can, but I can't deliver to you because I didn't reserve the capacity on the transmission system for that 15. Guess what? You better run your 25. Oh, but it's broken today. I really don't want to run it. You're in trouble. Your penalties are going to be huge. So capacity is a serious business. So that's why we don't say if we have 36.5 megawatts of solar, that's 36.5 megawatts of capacity. No, it's not. We better not bet 100% of it because it's too variable. A gas turbine is far more reliable, particularly a peaking gas turbine, with a counterparty that has willing to pay liquidated damages if they don't perform, is much more valuable in terms of emergency. That doesn't mean you shouldn't do solar, but what we're talking a lot about here is capacity planning, not just energy planning. It's capacity planning. And there will be a point in our future where we'll need more capacity because we know that we're going to be retiring capacity. We're going to be losing the 11 plus megawatts of Stanton when it retires. We're going to be losing 10 megawatts of GT of the combined cycle. So we're going to be losing about 22 megawatts of capacity. Now we're going to gain some of that back by taking a maybe 50% capacity credit on the solar, but we have to watch that very closely. And that's what the modeling is going to help us do.
A question in that context, and I think Eric might have referred to it earlier. One piece of the picture that you just painted, Ed and Brian, is you got to reserve not only the generation capacity, but also the transmission. Unless you are going to do the generation right here, then you don't need to worry about the transmission part of it. So in a environment where we are going to more variable energy sources, does the importance of keeping, particularly if it's a nimble sort of generator, keeping some on-site capacity generation, spinning generation, does that become more important? Does it become something that we might want to maybe think about a little bit more than we had in the past?
It does become more important. That's why the projects that we're looking at provide for capacity interconnected to the FPL network transmission system, as opposed to Duke or TECO or OUC. They're directly on the FPL transmission system. So there are resources under contract with a delivery point at our transmission interconnection. So that puts it on the FPL transmission system. So a megawatt capacity that's already on the FPL system is of more value to us than a megawatt that is not. So as a part of our solar projects, we have what are called exchange agreements. So in the FMPA contract, some of those plants are actually being built in the Duke territory. But we have an exchange agreement with FMPA that says a unit of solar that's delivered to us in Duke territory, they will replace it with a like-kind unit of solar on the FPL system. So that's a contract that's in place with FMPA. So yes, that capacity on the FPL system is more valuable to us than capacity that's not on the FPL system. Having it in our own system, while seemingly a good idea, the problem is that you can't build it at the sizes you need to get the economies of scale. to do that. So we need 5, 10, or 15 megawatts of capacity. You couldn't build it, and that's what the modeling is going to help us understand. I don't believe that you can build it at a rate that's low enough to offset buying capacity from somebody else. And that's a part of it. And keeping in mind that we also have to balance the financial side, that when we have to build it and own it ourselves, it decreases our borrowing capacity. We're trying to use our borrowing capacity to improve the distribution system. And capacity is really a commodity. So our view has been not to spend down really our borrowing capacity and our debt service capacity on something that we can buy as a commodity. But what I can't buy as a commodity is replacement of the poles on 6th Avenue South, for example, right? I have to rebuild those. I need that borrowing capacity to rebuild my distribution system. It gets complicated, right?
Yeah, no, I think that makes sense in your argument that there's a fundamental difference between the T&D part of it and the generation. One is physically transferable and one isn't. And you can't, we can't borrow infinitely, or we shouldn't, and probably can't. So, there's certainly some logic to that. I'm just wondering, and maybe that's part of the, it's an obvious thing to model, is would a small amount of nimble capacity on site that avoids transmission problems and gives us some variable capacity, would that make be a sensible combination? And
that's why we're keeping GT1 and GT2 for some period of time, because we believe they have capacity value. And you missed that earlier part of the meeting, but we talked a lot about keeping GT1 and GT2 while we
I caught some of it, but I might have missed those two. Yeah.
So while we would retire S3 and S5, which are very expensive, keeping S3 and S5 are costing us about $2.5 million a year in operating costs, without not even counting fuel costs, just to maintain them.
Keep them runnable.
Right. But
yeah.
GT1 and GT2, absent some great rebuild that they might need, we want to keep those for at least a 5-year period. And then sometime in 2024, after we get the second timeline built, we can open them up and see what kind of life extension or more serious repairs they might need to take them, beyond that 5-year period of time.
Yeah.
But we want to keep those as capacity plays.
The whole EUAB wants to come down and have a look when you open them up. I think we're all technical geeks that would get a kick out of that.
I'll agree with that. I would love to take a look.
We'll let you know. Come down. I don't know if we had people out when we opened up GT2, when we crashed the compressor. We had foreign object damage. We threw a blade in the compressor. We call it corn cob the rotor. That cost us $1.2 million. And then we incurred a $3.75 million in supplemental capacity fees.
Yeah, that was a bad year.
That was a bad year. That saw our unrestricted fund balances go to about -$6 million that year. And we're still at -1.7.
I saw David had his hand up for a while. David, do you still have a question?
I just wanted to say in the last meeting, Ed, you wanted us to ask the residents about what they would be willing to do. How much would they be willing to sacrifice for carbon and CO2 reduction? And I don't know if you want to talk about it now or later, but I talked to, so I brought it up at a neighborhood association meeting.
I think that input would be great. I think Greg and Kathy would like to have that. And the more input we get from the residents, the better. Now, granted, they're providing input in a vacuum because they don't understand the consequences, but through this modeling effort, we can begin to model that in and say, hey, what does it really mean?
Well, I told them, I told them that I was on the Electric Utilities Board, and I asked them, what would you want to do? First, I asked, what would you want to do for CO2 reduction? And everybody was in favor of solar. And then I said, would you be willing to incur a cost? What would you be willing to give up or sacrifice for that? And I put out a specific thing. I asked the group, would you be willing to pay $25 a month more so that money could be invested in CO2 reduction via solar? And most people said no. Out of the group, 2 people said yes, and one of them was a hardcore environmental activist. All right, that was at my neighborhood association meeting that last week. Mango Groves,
Well,
make-
25 a month is a pretty big chunk for people.
25 a month.
Did you try any other numbers, just out of curiosity?
Did I try what?
Did you try any other numbers, say?
No, I
50?
just put that out as a yes, no question. And most of the people were like, no, 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 we're paying enough already. You know, if you add, and then I asked, I was meeting with a few other friends of mine, and I asked them, there was like 3 people, and they were more willing to pay, but they were there said, well, yeah, it would have to go. If I knew it was all going to invest in CO2 reduction, I would be willing. That was like 3 friends. So just sharing that information.
Thank you, David. I had a similar response to the Sunset Ridge neighborhood. I asked that at my last association meeting, as well as to a handful of other individuals about if they would want the city to commit to a 2050 timeline to go net zero carbon emissions. And they were like, oh, yes, definitely, let's do that. But then at the same time, I said, would you be willing to pay more for it? I didn't put any dollar number on it. And they're like, no, of course not. I don't want to pay anything more than what I'm paying now. So I think the consensus as a whole is that people love the idea, but they don't want to open up their wallets to support it. So if there was a way that it can be explained in a somewhat better way, or a more palatable way, you know, because another question I haven't read yet from Ramsey, board member Ramsey Stevens, was about the Inflation Reduction Act. We can get to that in a minute, but yeah, most people I talk to, even on the streets and whatnot, they said their bills are high enough already. They don't want to pay more for anything. They don't care where their power comes from for the most part. But if we could go to a net carbon zero, then they would appreciate that. But I just don't feel that the consensus is they want to pay for it.
And I think that's where this issue of somehow helping people understand through the modeling, what is your exposure or your risk reduction to price variability? If one had presented it, and you'd have to think about how to present it, but if you said, look, if you had a guaranteed rate, you know, would you accept $2 more or $5 more, whatever the number you want to pick, or a couple of them, but you know that your rate is going to stay at that for at least half of your bill, or 30% of your bill, or 70% of your bill? Would that be worth it to you? And you get a carbon benefit out of it. I think you'd get a different answer.
Yeah, I definitely believe in the way you phrase the question, you get a different response. And that would be a good answer, like a guaranteed cost versus fluctuating, because people do not like the adjusted fuel charges on their bill, especially now.
Yeah.
The prices are high. They like, where'd this come from out of left field? I don't want to pay more for this. What's going on? Because people don't watch natural gas prices. You know, they don't really pay attention to that. They just pay attention to how much the iPhone costs this year.
Okay, if we gave them a guaranteed rate and we added a couple bucks to go to a developing solar, but it didn't fluctuate, would we come out ahead with that arrangement? Would we come out ahead so we would have money to invest in solar?
And it depends very much on what you figure the future. That's where the modeling scenarios come from. You know, do you figure natural gas is going to stay at the current 9 plus whatever the basis is for getting it here? Or do you think it's going to come way back down? What do you think about carbon taxes? What do you expect for that?
The unspoken thing here is, sorry, I didn't mean to interrupt.
No, go ahead.
The unspoken thing here, at least so far, is if we're going to talk about rate stabilization and so on, it's a measure of variance, of variability of rates over time. And that is something that's directly measurable across these scenarios. We could measure that. And of course, that volatility is a measure of variance. So if there are measures, if you lock in rates through some series of technologies, that is a risk reduction. But the point is, people then have to give their risk preferences and say, how much is that worth to you to reduce the risk? So that the value of risk reduction would then have to be embedded or understood to know how much rate stability is worth to the community.
I think even doing it and that makes a lot of sense, that to model it fully, you'd need to know what's people's, what's it worth to people to have less volatility, more exposure, less exposure. Getting those numbers would not be elementary. There probably are some literature numbers on some of it, but even simply being able to show people different scenarios and say, look, this scenario, look at the variability. It could go up, could go down. That we don't have crystal balls on natural gas or other fossil fuel prices, but I think Ed would agree, they're likely to go up, not down, in general. And look at this other scenario. It's maybe a little more expensive, but it's very stable. I think simply showing some of that would help people make more informed choices between options.
And all of that predicts the same rate model that customers are paying right now. So, I mean, I know we've thrown around time of use, I'm sure there's people that are not in their house all day, and they would be completely okay with, I mean, I don't know how solar affects time of use. But if they're like, yeah, at 9 o'clock at night, I'll run everything. I'll delay my dishwasher. I'll crank down the AC to 65 and get all the cheap power I need. And then, kind of, ride through or go to work during the day, and I don't have to worry about it. So, I mean, I think there's other things, but people are looking at the current model, and having worked at utilities for the better part of a decade and doing surveys with customers, a customer will tell you are doing everything right except the rate. I'm pretty sure that any customer is going to say the right rate is 0.
Exactly.
It's just human nature. So I mean, I'm not saying we don't need to worry about that. That is absolutely what I'm saying. We need to be very sensitive to any kind of change in costs associated with it, but we also can't, say that, oh, no one wants this and let's just move on. So
I think that, I like all that feedback. That's excellent feedback. And what I could say is, knowing a little bit about the modeling that Greg and Kathy have already done, and I know we haven't gotten to talk about that yet, but I can tell you, regardless, even if we didn't care about carbon footprint, we'd be saying, if we only looked at cost right now, we'd say, grab more solar and some more gas-fired peaking down the road. So the solution that I think, and Greg, correct me if I'm wrong, but we're at an interesting point in the marketplace in the history here where the low-cost option for us is the low CO2 option.
Yeah, exactly.
Is that correct? Did I say that correct, Greg? Does that make sense?
Well, of course, we run different scenarios, right? We're doing scenario analysis and we're doing it over 20 years and so on. But if you look at the levelized cost right now of resources, it's definitely not natural gas fired or coal. If you're looking right now, the wind is taking a leap up and solar is taking a leap up too, but it's still probably the cheapest. Yes.
So, to the extent that we're going to have gas-fired generation in our portfolio in the future, it's going to be to maintain that capacity position for when solar doesn't work. But
it's the fill it
energy is going to
storage.
Right. The lower cost of energy is going to be at the moment, in this, we do IRPs every few years, and the big companies do them every year, by the way. But the fact that we're doing our second one in just 4 years is unusual. But it's good. But we're probably going to find out here in this exercise that solar is, for the purpose of this plan, is going to be the lowest cost path for energy, whereas considering peaking capacity on natural gas is going to be a part of the solution. But just because you have peaking capacity on natural gas doesn't mean you're actually going to be running it all the time. You're going to run it for that reserve requirement, for that capacity value. And in that case, it's going to be important that it be on the FPL transmission system and you nominate it monthly. and you're not
I'm
going to
a-
be able to build it. So that's my intuition as to where we would wind up, and that's in fact where we seem to be headed. Now we're at 8:36 already, and Greg and Kathy, you had some more slides I think that you wanted to show us from the modeling. Were you planning to do that tonight too, or?
Actually, I'm not sure what slides you're referring to. Sorry.
Oh, some of the stuff that we went over on a conference call, the Zoom call 2 days ago in my office.
Okay, I can show those slides.
Were you planning to get into that tonight as well?
We
By the way-
can. I think folks might be wanting to move on here.
I just want to interject.
We can end
on
this
this
soon, but
spreadsheet here-
I wanted to.
Oh, sorry. Go
I'm
ahead.
sorry. I was just going to say, back to your point, Ed, of how solar seems to be the most economic solution, and it also reduces carbon. And then we would need gas or whatever fired plants to anything that produces CO2 to fill the nighttime or whatever we have. That, as much as we can mitigate that need with batteries, sounds like a great plan.
Yeah.
As much as we can do to reduce the amount of CO2 that we produce when solar is not enough, because it's Florida, it's always pretty sunny. And so as much as we can do to just get away from that and have batteries to store the sun when we don't need it, or any other sort of option. But I think for Lake Worth utilities and the size of it, batteries might be the most economic. That makes a lot of sense. And I just wanted to put that out there.
Yeah. Well, Florida is always sunny, generally speaking, but when you look at the actual output of a solar power plant, you'd say, "Ooh, wow, it's not quite as always sunny as I thought it was."
Yeah, I can show you my day-to-day solar output on my graphs. It's not a nice bell curve. It's kind of like up and down, like more like an EKG. It's like it's just going all over the place.
But the storage, I look at those curves all the time because of my field installations, and I've looked at bunches of them, and I've looked at the ones from our solar field, and you're right, but you can always still see the bell-shaped curve in there. It's just you've got those dropouts, like Ed said, that you may go from 1.5 kilowatts to almost nothing or pretty low, but then 5 minutes later, you're back up again. And so when you integrate the area under the curve, the cloud cover rarely takes out a very big bite of it. It makes it very noisy, and that's where the battery part comes in to smooth that out.
Yep, indeed. One thing before we go back in the spreadsheets, I know the one sheet you did show had the Ocean Current Energy Project on there, and I know there's a presentation coming up in a few days. Do you have any insights as to the viability of that project before the presentation is made, and if there's an ETA on the technology and an update on whether or not that's going to be viable for what our needs would be for a constant source of energy, or is it still a very highly theoretical thing right now?
So we had it primarily in the model just based on discussions from earlier, and frankly, we had it in the model in 2018, so it kind of made its way forward. But our discussions to date, we have it's a very expensive, even our guesstimates on capital costs based on a research project, I believe in the New England area, is a very high capital cost. And we have operating characteristics for it. We included it in the resource plan. But I guess that's the update, is that we have it in the plan and it's available. We don't necessarily, we consider it to be still a very immature technology, and we don't foresee it necessarily being added to the plan, or certainly not within the next, let's say, 20-year time period.
Thank you.
There are currently no commercial scale units available in the marketplace. They just physically don't exist. There's a bunch of trials that have taken place for our type of application, but nothing going to be significant. Maybe 10 to 100 kW type of stuff. There are some, certainly one of river hydro, pump storage hydro. There are some tidal units in shallow waters that are in use around the world, and obviously in rivers in remote areas of the world that are providing great value to very small communities, but nothing of the scale that would operate at the depths and pressures that you would have with the Gulf Stream and then connected to the mainland. The effort that we're focused on right now is helping and hoping and helping to get some grant funding for the Ocean Current Energy Project to really develop the ocean bed off of our beach as a test lab where manufacturers, inventors can bring their equipment through Florida Atlantic University and the Southeast National Marine Energy Research Center to develop their turbines to get them to the point where they can be commercial. So our focus now is on getting that, if you will, underwater laboratory built. Gabe Alcinas, who's the director of the research center, which is a DOE research center, it's housed within Florida Atlantic University. He is coming to speak at the next commission meeting to give the commissioners an update on potential funding opportunities which may exist within the DOE. And then we're hoping to host our lobbyists from FMEA, which I'm now an officer of, to engage our state and federal lobbyists, get them up to speed so that they can help spread the word together with FAU, with the DOE to free up some DOE dollars to support that research effort. So, but it's just not anywhere near where I would say I could responsibly recommend to you that it be part of our resource plan at this point. It's just not of that scale yet. I believe it will be one day, but it's just not there yet.
And having gone courtesy of Ed up to Harbor Branch to see the facility was pretty cool, but I would agree with Ed's assessment there in terms of the commercial.
Vice Mayor Red Boy and I could spend all day up there geeking out on all the cool stuff they're doing.
Oh yeah, there was cool stuff, no question about that. But
probably be willing to work part-time as a volunteer up there just to help them tow stuff and test it and work in machine shops to develop it. But it's just not ready for us to say, yeah, we're gonna get a megawatt or 2 or 3 of our power from that in 5 years. Now it's not there yet.
And just to touch base on how the solar does fluctuate. Today, our own solar farm went from 1.2 megawatts at 11:10, just over 1.2 megawatts, to 99 kilowatts at 11:20, and then back up at 11:35 to 1.3 megawatts. So, I mean, that's significant. If you put that on a larger scale, that's a huge jump.
And we can bet that all of the customer-owned solar on the system is doing the exact same thing.
The exact same thing. Yeah.
We probably dropped, 2 megawatts of load within 10 minutes, and then ramped it back up. So who absorbed that spinning reserve?
And the answer in the future should be us.
Right, we're getting billed for it. At the moment, the economics aren't there to justify the battery for that, but I believe that that's coming.
Well, and an interesting thing to think about in that context, suppose that you were looking at a thermal system. So you're looking at a solar hot water, like there used to be 60,000 of them in South Florida in the 40s or 50s, I read somewhere recently. And you look at it generating hot water in your tank, and that noisiness in the signal is totally irrelevant in that situation, that it's got the storage built in. So I've been thinking I need to tell Ed that he needs to swap jobs with our water utility guy. It's a lot less headache, because it's easy to do storage, but Eric has alluded to it. Storage is a very key part of this, and then you don't care about that jumping up and down.
Believe me, Vice Mayor, there's plenty of nights where I've gone home wishing I could be in something as boring as water. But especially after.
But we have a more interesting area.
After meeting with you some nights.
Yeah, exactly.
But yeah, we one day hope that electric will be that boring, but it is complicated stuff. And I just want to make sure everybody understands what we're obviously talking about a lot of detail here, but it's not to scare you off the concept of the reality of what we need to do here. This is a complicated business, and I appreciate the fact that all of you have spent so much time as members of the community volunteering your time to understand all of this, and then to be really the king's messengers for our commission and our utility, talking to the community. I can't understate the importance of you talking in your communities to bring that feedback back to us. It is important. This is community-owned energy. This is the real deal. This is not a guy in a helicopter or a woman in a helicopter making the decisions far away. This is right here in our city. We make our decisions for our community energy, and we need your feedback on what you want. What do you want to own? What do you want your mixes to be? What do you want? Yeah. Okay. Is there anything else we should cover tonight?
Yeah, were there more slides or was that it for this evening?
Hey, Ryan, I think there was the one last question about the.
Oh, you are correct. One last question. Let me go find it. All right, question number 3 from board member Ramsey Stevens. How has the passage of the Inflation Reduction Act influenced Horizon Energy's modeling?
Yep. So the short answer is we've updated the schedules on ITC, PTC, investment tax credit, production tax credit for the different technologies into the future that were affected as part of the Inflation Reduction Act. We had to make decisions as to which part, which additional kickers there are in the IRA, things like domestic content, which we've made those choices and put them in the schedules for recovering those incentives. We're continuing to evaluate. So it was passed 8 days ago. So we're still continuing to look for that second level to see if there are needs to include additional technologies in the resource choices. But the primary impacts are on the are in the area of the production tax credit, investment tax credits.
And well, and also I think it's going to lead to further discussion with Ed and the board regarding assumptions that you want to make on energy efficiency as well as electrification, because there are incentives in there for energy efficiency that are consistent with some of the assumptions we talked about in the last meeting, where you were saying, well, you've got somebody who owns an apartment building that has really no insulation, poor windows. Well, there's incentives in there now for that person that owns the apartment building to make those revisions. So that's something that we would be looking to Ed and the board to give us some guidance as to what you think the levels of penetration may be for Lake or Beach.
We're certainly, I can add that as a commission, we're certainly looking to increase those levels of penetration, both through the IRA and through self and anything else we can think of. Another thought that comes with that, or came to mind as you were speaking, Kathy, is suppose somebody does upgrade the insulation in a building. I think it would not be crazy to expect that at that point, somebody might be more willing to join a demand response program because they know that they can coast a little bit better. Whereas if you've got a very leaky building, and somebody says, hey, you willing to turn your AC off for 10 minutes? And they say, no. But if you've experienced that you've insulated your place, your windows are better, hey, I could coast for an hour. It wouldn't make much difference.
Exactly. Yeah. So that's going to impact, the levels of energy efficiency, and demand response, and even electrification for electric vehicles, because there'll be incentives there as well. So you'll see it's possible they might all just offset each other, really.
Or be synergistic in that you have more buffering from some of that.
So one of the good things in the act, though, for us as a city is that we're Vice Mayor knows the financial situation just as well as I do. We're not in the position of sitting this own board recommended not spending a lot of money on rebates and inducements for customers to go do things like windows and air conditioning and insulation. However, having said that, the act does bring some significant dollars to it. So things that we can't afford to do as a city, but very much thought would be helpful, but we just can't afford it, that money may come from the federal government now. So, and I think it may be even more than we could have ever done, right? So it can be rather significant.
It looks like.
We don't know the rules yet because they haven't been written. So the Washington right now is full of staffers that are writing these rules, but what they approve is really a high level wish list. But that's the other thing that we'll have to make a decision on is on some of these things, whether we want to do power purchase agreements or own things. And we're going to be reaching out to our financial advisors. I've had a conversation already with our director of finance on that. He suspected, as I did, Vice Mayor, that it would make more sense to have PPAs as opposed to owning things. But we are going to engage our financial advisors to help guide us on that decision making and render an opinion when we have something a little bit more concrete to talk about with them. But we'll bring them into the loop.
Well, and Ed, I may send you another summary of the Inflation Reduction Act that gives more detail on what the structure of some of the incentives would be for the different programs. It gives you a little more outline structure on how it's going to work.
Okay.
Great.
All right. So Chairman O'Blander,
Yeah, I think we covered a lot tonight, and we'll keep on going into the community and getting more feedback, and especially with these questions about offsetting stability versus fluctuating gas prices. Gives us a little bit more backing to our statements and questions, and so that the people who know about economics, will give us better answers. I thank everyone tonight for hanging out this long, and I think we should probably wrap it up. So if I don't have any objections, are there any board comments or liaison comments that we haven't discussed this evening before we adjourn?
I would only echo Ed's one, that it is a very cool thing that people are willing to put time and energy, and thank you to Greg and Kathy and Ed also for helping to educate us all to make better decisions.
and my cohort here, Brian, who's
Yes.
That's what
Yes,
we're
Dave.
here for. That's what
he's
we're
like
here.
6'6" in person. On the phone, he's just a little square on the screen here, but in reality, he's 6'6".
Yeah, thanks, Brian, for joining us.
Thank you.
Matt, were you going to say something? I saw your box light up.
No. I was just gonna say nothing from me. No comments from me.
Okay.
I think everyone's heard from me enough.
All right. Do I have a motion to adjourn?
Motion to adjourn.
Second.
All right. Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you all.
Good night.
Thank you.
Have a good
Sue.
night.